Happy Friday. Happy, hopefully, Flight 13 of Starship. I'm feeling good about this. The weather looks great. I don't know. I'm ready. It's a beautiful Friday. I think everyone's ready to see an exciting launch. This is, of course, this is SpaceX's Starship rocket, Flight 13, the 13th launch of a full stack of their enormous Starship rocket. So I'm excited because this is kind of a follow-up to Flight 12, which was, as far as new, like, big changes in the program, it was by far the most successful. They still have things to figure out before they continue on. Those of you that follow along here or any of the space flight channels, often you probably know that this rocket is less about like dates and times, and it's more about seeing milestones and progress. So we're really hoping today to see a beautiful, similar trajectory to what all the previous 12 flights before this have been, which is basically a suborbital flight test. We, of course, are going on a little bit early as we are seeing them work on cooling things down. They've been chilling. We've seen tower vents. We've seen them, going to get ready for the rocket. Everything looks good. Everything looks on time. And in fact, some things actually look technically ahead of schedule, or at least ahead of like what we're used to seeing. So they started spooling up the tank farm and started getting activity going on that quite early. So that's great. So everyone watching, fingers crossed, really hoping that today is the day that we see, some real action. We see a launch. It's been over a week scrub, which frankly feels almost unusual these days. But as you saw on the side there, we did kind of have some milestones that popped in for a second. Those are kind of the next things we expect to see. We have 35 more minutes until there we go. The poll goes for prop load. Now we don't always hear that. We don't hear the internal loops. There's no, official X feed up at that point. But sometimes we will get like a statement from SpaceX on Twitter or on X that says, that we are go for propellant loading or whatever. And then we won't actually see prop loading until after T-minus 40 minutes. Remember, they fill up the world's largest rocket in under 40 minutes. Like, that is absolutely wild. By far the world's largest rocket. It has over twice the amount of propellant that the Saturn V had. In fact, it had a lot more than that, because the Saturn V actually by actual mass of propellant didn't have because they used hydrogen. Hydrogen's not very dense. So although the Saturn V was really big, by total mass, it was a lot smaller than this rocket, a lot less massive, I guess, would be the technical thing to say, than this rocket here. So this rocket has over twice the thrust of the Saturn V that took humans to the moon. And there it is, sitting on the launch pad, looking fantastic. So this is, of course, Booster 20 and Starship 40. This is the 20th booster they pretty much built, and the 40th-ish ship that they built. Now, don't forget, some of these ships, they'll start with something and just an aft section or maybe a few barrel sections, and they'll be like, oh wait, we're moving on to something else, and they'll totally move it into something else. So people asking if audio is messed up, I think that's just the sound. We do have the sound of the tank farm running in the background, so if you hear that, that is the live launch pad. We don't always get to include that, but we actually do have that this time, which I prefer to have that versus not having that. So you are hearing some of that static and some of the stuff in the background. That is real live audio from the launch pad. So we want to hear that because we want to know if something's happening. You can kind of get a sense of how things are going along. But we'll kind of keep it in the background for you guys, so if everything's going well. And so far, like I said, everything is tracking quite well. So this is a great question. We're going to start off. Remember, if you would like to ask questions, just ask a good question. And our amazing moderator team, Ty Mods, thank you for being here on a Friday. Some of you late Friday, over in Europe, and the rest of you, hopefully you're off work. And everyone say thank you to the mods. We are going to be doing a few questions. So obviously get your questions in now. This is the best time to do it for the next hour, basically, until the X feed starts up. And once the official hosts start listening, or start talking, I start listening, and I like to just be more of a passenger during that period. So get your questions in now. And of course, thank you for those of you that do support, but don't feel like you have to. We'll get through as many as we can. But let's start off with this. This is a great question. So this is from the JJ Zone. What goals remain to get to orbit safely? Really good question here. What goals remain to get to orbit safely? So, and you're saying it right. You're looking for goals and milestones. I think a lot of people say, when will they get to orbit? It's not so much when, it's about what is next in this test process, in this prototype process. Do we need to see them achieve? What things do we need to see them achieve before they can reach orbit? So technically, don't forget, this rocket, even, technically from the first one, has had enough potential to get into orbit. Like, there's enough propellant on board, there's enough, engine thrust, there's enough performance to reach orbit. They're intentionally targeting a suborbital, just barely, by only a few hundred meters per second, a suborbital trajectory, so they don't accidentally get the world's largest flying object ever made, which is Starship, stuck in orbit and not able to come back down. So they're trying to do things safely. They're trying to do things iteratively. And the next things that we're still seeing, since this is a new rocket, this is the new version 3 Starship that first debuted in May on flight 12. This is the second flight of this version 3 vehicle. We're going to want to see them still have another successful reentry with the ship. And we need to see a successful booster reentry. Actually, ironically, the booster part, as long as it performs, which it did for the first one, for Flight 13, they don't need to catch the booster or do any recovery for them to get to orbit. That's kind of the important thing to remember about a vehicle like this and about a program like Starship, is the hard part is actually the recovery part. The getting to orbit part would be relatively, way easier for them. So if they weren't trying to get and do reusable vehicle, they could get into orbit like on flight 3 already. So this is a bit different. So what we need for sure another reentry safely today with Starship, where it comes back in one piece. They might continue to stress the limits of the vehicle and push it to kind of more extremes to make sure they have the full envelope of the reentry profile. Kind of have, you want to kind of get those edge cases out, like how big of a banking angle can I achieve before, the flaps stall out or something, before we tumble and lose control. So they're going to be, they're kind of pushing that envelope so that when they do come back in for a reentry and a reuse of the upper stage, they have tested it all out and they know they're not going to break up on reentry, because breaking up on reentry would mean large chunks of a vehicle, landing all over, potentially populated areas over Texas and or Mexico. So, and even potentially other states. So you really want to avoid that. That's why they're doing this nice and slow. And so, yeah, so the next big milestone is hopefully we see another ship reentry that's nice and safe. And meanwhile, hopefully we see a nice soft splashdown of the booster as well today. Assuming those things go well, let's say Flight 13 is perfect. Let's say Flight 13 goes every milestone, checks it all off. I'm not sure we'd see orbit on Flight 14 yet. It might still be 15. Because they definitely will need to do a Raptor relight test. That's one of their objectives, is they have to relight once they're in orbit. They might want to do that twice to prove out they absolutely can do that on version 3, since they're new engines and all that stuff. Since they did not get to even do that once on Flight 12. They did not do a relight on Flight 12. So orbit might be more like Flight 15, but we'll have to see. If this goes perfectly, they might just go for orbit on 14. However, they might not go for a catch on Flight 14. So from the ground side of things, it'll all look about the same. However, if it does get into orbit, they could actually deploy into orbit proper V3 satellites. So this launch has V3 satellites, but they're not going into orbit. They're going suborbital along with the rest of the rocket, and they will re-enter very shortly after. But it's a good onboarding process to make sure that they're integrated into the stack, and that when they deploy them, everything acts normally, so that when they're ready for orbit, we're happy with the results, and it moves into that. So let's sorry, that was a long one. Let's see here. This is a good question from PDM Taylor 32. After watching the recent morning launches that caused jellyfish, has anyone calculated the size of plumes on launch? I don't know if anyone's calculated how big. So they're talking about, like, specifically the jellyfish phenomenon is actually backlit scattered. Basically when it's dark on the ground, so either before sunrise or after sunset when it's dark, and a rocket launches. If it's on the East Coast, if it launches before sunset, you can have the exhaust be backlit by the sun. So as it gets higher up, all of a sudden the exhaust can be illuminated by the sun, and it can glow, and you can get these big, beautiful, crazy clouds. And then the same thing on after sunset on the West Coast, you can get those jellyfish phenomena. I don't know if anyone's measured out. It probably would be relatively easy, because you can actually see sometimes like the diameter or the length of a known object, the upper stage. And you could probably calculate out from there how big relatively it is within a certain degree of, yeah. Let's see. Let's keep going here. From Conan 77777. Godspeed Flight 13. Thank you for being a member for 53 months. You are amazing. Let's see. How mature is the reentry shield? Asked the JJ Zone. Again, another good question from the JJ Zone. So it looks like it's really doing quite well. It looks like it performed very well on Flight 12. The vehicle did like a pirouette. It kind of did a 360-degree spin so that their cameras could capture all angles of the ship. And it really does look like the ship's heat shield is performing quite well. There's no missing missing tiles. They're not even playing around with as many experimental tiles as they used to. So they seem to be quite happy with the decisions they made. But for a little while, Flight 9, 10, 11, they were, 9, 10, 11. They were definitely playing around with different, with missing heat shield tiles, with different heat shield tiles, with all sorts of things to see what really does perform best, for reentry and for rapid reusability. Like what if they actually caught this thing and land it? Is it ready to just go out there and fly again? Are the heat shields going to stay attached? Are they going to be, broken or cracked or, they've iterated a lot on the heat shield side of things, which is quite exciting. That's, again, something that the space shuttle didn't really have that freedom, right? The space shuttle immediately went operational, basically. It had 4 test flights, technically, but all 4 of those had humans on board. And when you have humans on board, you're not just going to be like, hey, let's take off a couple heat shields and see how it performs. And let's try changing up the material on the heat shields on just a couple spots. It's like you couldn't do that during the space shuttle era. They couldn't really iterate on top of what they had already, kind of come to convention with. And now with Starship, they have that freedom because no one's on board. There's no paying customers. They're just doing giant test flights. And that's personally why I find this program pretty exciting, is because you are seeing that freedom to make changes. And if something's better, they'll try it. If something's worse, they hopefully move on from it. So I've found that to be quite fun. Notice on the left-hand side of your screen there, you can see a little edge of Hopper, the original vehicle prototype that's still out there at Starbase. On the right screen, you can see Hopper. Just for some perspective, you can see the tower on the right, and then you see kind of the smoke plume, or not the smoke, it's condensation plume, the white cloud, and the white towers. And if you keep going all the way to the left of where those clouds are ending, you see a little shiny little trash can. That is Hopper. That is Star Hopper, and that flew for the first time in 2019. It flew only kind of two little hops in 2019, and that was just the first, like the roughest prototype ever of how do you make a vehicle hop, and how do you make a vehicle operate with methane, and how do you operate a full flow stage combustion cycle Raptor engine. It was very primitive, but it got them off the ground physically and, quite literally. And we've moved on from there, which is really fun. This is from Aubrey J. Phillips. I started working at a machine shop a few months ago, which creates parts for Starship, and Ship 40 has some parts that I had a hand on it. Super excited to light this candle. That is awesome. Congratulations. That is really fun to see and know that, there are still people out there that don't even work at SpaceX that have physically had their hands, and even other companies that have their hands on parts that fly to space. I just think that's awesome and part of pretty big and exciting missions. So let's see here. Let's move on. Oh, you know what? I had to do something. I forgot to, or maybe Andrew could do this, but I forgot to label that this is our 4K stream. So Andrew Taylor, if you can edit the title. I think I forgot because I originally replaced the words 4K with scrubbed when it scrubbed last week. So yeah, let's keep going here. From Big Blue Biosphere, why did it scrub last time? Sorry, I didn't watch. So last time it got all the way to T0 and 4 engines basically didn't light. Now we don't have a ton of information on why exactly that is. Some rumors were swirling. I don't really want to repeat rumors just in case they're absolutely exactly rumors. But it sounds like 4 of the engines, for whatever reason, decided not to light. And they ended up having to replace a few of them. So they took it back, and it looks like they're, got them all in there. Now they did some light tests yesterday, or 2 days ago now. Was that 2 days ago? Because, yesterday 2 days ago, they did some light testing. They still didn't do like a full spin prime or anything. So we'll see. They must feel fairly confident that the replacements are good to go, and that everything's, that we hopefully won't see that happen again. But I don't know. I'm not putting any bad juju out there. This thing's flying today. I'm all for it. This is from Tim Havens Jr. saying day one of petitioning to name the epic new Pad 2 ignition sound the Kawoosh in honor of Save Stargate. That's funny. I need to hear better. We have not had really good pad audio recordings. We had an issue on Flight 12. I am excited to hear really clean audio of the Kawoosh, as you call it, to know what it really technically sounds like, at a very high quality. We're on a everyday astronaut side of things and cosmic perspective side of things are going very smoothly. We have more cameras working better. Because of the reset, famously, you guys probably know how this goes by now if you've been watching for a long time. That resets afford us the ability to kind of go through, grease the wheel a little bit, get some things out and fixed up, and that's exactly what we're able to do. So a lot more cameras are running tippity top today, so we're really excited about that too. So. Hyman Zahara says, why don't they just fill the trench with water like they do for Falcon instead of running it for 17 seconds before engine startup? So, that's a good. I don't know. Does Falcon actually just fill the trench with water, or is there just always residual water? So one of the things is you definitely want water flowing. You don't want stagnated water. You don't want to flash boil a huge giant pool of water and have that potentially have like almost explosive energy. You want water flowing. So that's going to be one of the things. And you want it to be continually flowing so that as soon as the water does evaporate and flash evaporate basically and take some of that sound energy and heat energy with it, you want more water to replace it. So it needs to be flowing anyway. But why? Yeah, I think the answer is just simply that they want it to be flowing water and a lot of it at ridiculous flow rates. I think that's the main thing. I see one that I'm just going to add to the queue. Maybe a mod can find it from Mary Nesling asking, what's the best possible outcome for today's launch in regards to data collection? If I see it in the queue, I'll throw it up. Oh, perfect. I see it in the queue already. I'm throwing it up on air. Did it go on air? Yes, it did. Okay, so from Mary asking, what's the best possible? I just like this question, so I had to just throw it in there. And we can slow down on the questions for a little. I realize how big my queue is here. Sorry, everybody. Best possible outcome today is that we see, first and foremost, a clean liftoff with all 33 engines. No drama leading up to that. We get to stage separation. Spencer, if you want to pull up flight, the middle flight things, I can give us some times on these things then, the little timestampy things. But there we go. So yeah, hot staging. So max Q happens in under a minute, which is crazy. That's how fast this thing is accelerating. And don't forget, max Q is never like a fixed number. It's not like all rockets hit max Q at 1 minute and 34 seconds, or it can vary so much by profile because it is about how fast, as you speed up, like if you're at sea level in a car speeding up, obviously the faster you go, the greater the air pressure, the air resistance is on the vehicle, right? You can feel that if you stick your hand out the window. The thing that's really unique about rockets is obviously as you go faster, that increases. However, you're also going higher. So the atmosphere gets thinner and thinner. Because the atmosphere is getting thinner, eventually there's like this cool convergent point where you're going faster, but the atmosphere is now thinner. So even though you're accelerating, the total pressure is actually dropping. And so that's max Q, right? Right before that moment, the moment of maximum aerodynamic pressure. That's exactly what that means. So, but the fact that it happens in under a minute means it's accelerating like crazy. It's shooting off the pad very quickly. So booster MECO, that's most engines cut off, is at 218. And they very quickly start flipping and hot staging almost immediately. And the reason is, I kind of talked about this last stream, but this is hopefully a good time to do this now. So remember, obviously the booster's job is to get the ship out of the majority of the atmosphere, right? You got to get the ship basically in space so that it can light, vacuum engines that are rated and designed to be as efficient as possible in space. So the booster's, primary job is to get it off the ground, get it out of the densest part of the atmosphere, and basically get it into space. And as it's doing that, it's starting to go horizontal because it's trying to give horizontal velocity to this upper stage. The more work the booster can do, well, you almost need to think about it like this. Let's say you have I'm making up a number. Let's say you have 10,000 kilograms in this. It can do so much work. If you have 20,000, the same stage can do less work because it's pushing more mass, right? Which means the booster would have to do more work in order to make up for that. So you can think of it as like the more work the booster can do, the heavier the payload you can put on your upper stage. So they want the booster to do as much horizontal work as possible. However, the double-edged, the triple-edged knife on this whole situation is that as it's doing that boost back burn, and as it's doing the ascent burn, it's moving further and further down range because now it's starting to go, horizontal, starting to inject more velocity in the upper stage. And so as soon as it lets go of the upper stage is going on to orbit. The booster at this point is traveling away from the launch pad at like thousands, like 3, 4, 5,000 kilometers an hour, like absolutely ridiculous, like Mach 5 or something, just screaming away from the launch pad. And they're trying to bring it back to land on the launch pad. So what that means is the longer it takes to turn this thing around and light up its engines like a Falcon 9 and do that boost back burn, each second that thing's moving away at like, a kilometer every second or something ridiculous, whatever it actually is. Yeah, faster than that, actually, like 1.5 kilometers a second or something. So the faster they can do that boost back burn, so as they do the hot staging event where they light the engines, the upper stage is going to go off and go away. The booster is going to flip and turn around as quickly as possible so it can slam on the brakes, basically, right? It's going to light up. Now they're trying to light up all 33 Raptor engines on the booster and basically slam on the brakes so it stops going away from the launch pad. And then they'll just give it a little bit of a little bit of extra velocity to go back west. So it goes backwards. And then luckily it's falling. It's falling from altitude. It has the grid fins, so it can basically glide back down. You don't have to do the boost back burn, so the ballistic trajectory is all the way back down to the launch pad. You aim short of that and let the the aerodynamic forces bring it the rest of the way. Really cool, really fun. Why am I going? This is a long rant. What? This is all about. This is all about this. What's the best possible outcome for today's launch? What am I doing? This is the longest. Sorry, everybody. Best outcome is that boost back burn looks really good. The next possible outcome is the booster does a soft splashdown and does targets a good 20 miles or so or 30 kilometers off the coast in the Gulf. It'll do a soft splashdown, which means it'll have a controlled landing burn and kind of hover there, and then they'll shut the engines off and let it crash into the water. But basically simulating a tower catch without the tower there. Meanwhile, the upper stage hopefully has a clean ascent. Does all, let's go of all, oh man, I'm already forgetting now. Is it 20 or 30 version 3 satellites? Can someone correct me? I forget if it's 20 or 30. Yeah, they'll let go of all the version 3 satellites. They will do a Raptor relight test if it all goes well. And then hopefully, again, they'll have a nice soft splash, re-entry and splash down to the upper stage and a clean landing burn so that they feel like they are happy with it's 20. Thank you for reminding me. 20 satellites today. I have lost my mind. But there you go. That's what's going on. Let's try to answer more questions because I am ranting today. This is from Kai on Space Runners. Why are you not using your Shure SM7B mic? Thanks for the stream. So the reality is SM7B just takes up a lot of room, and it just kind of looks, when you're sitting here talking all day, it just looks ugly. And we're using what's basically essentially a shotgun mic. So it's a mic that you'd use like in movies and TV when you have it, over the people. It is a touch roomier sounding. I mean, the SM7B sounds like it's like right there in your mouth. This does sound a touch more live. But I don't know. I think it allows me freedom to do this kind of stuff without knocking stuff over and bumping stuff. I still think I prefer a 7B for general audio, but at the same time, this is important. What is the flight profile of this flight? Almost the exact same as Flight 12. So we could actually show like a flight animation of kind of what that will look-ish like. It's a rough, gives you a rough sense of what that looks like. Let's see, this one here. So yeah, this one's good. You can see the orange line there is going to be the booster, or the blue line is the booster boosting back, and then basically exactly like that. And the hot staging and boost back burn all kind of integrated into each other. Meanwhile, the ship will go south of Cuba and go basically around the Earth. Engine cutoff there somewhere after a few minutes. It goes all the way over South Africa, basically. And then it more or less comes back. It'll land off the coast of Australia. Same flight, almost the exact same flight profile as all the other ones. Yeah. Let's see here. So this is from 01 Vlad 01. Are you going to make a Starship model for sale? Someday we will. Well, it takes like 2 years to be able to go through all the process, like the prototyping and all that stuff of these models that we make and sell, because we do like molds of them. These are not just 3D printed. You know, they're, those of you that know, you know, they're metal, they're heavy. This weighs like 2 kilograms. It weighs like 4 pounds. I mean, the shipping cost, I think, that's the primary driver, is how heavy this is, because it's a solid hunk of metal. We want to do a Starship someday, but we want to wait until it's, you know, stops iterating every 2 months. So we might do one again, like maybe in a year or two, but I also want to have new models come out. You know, besides we had our Mercury Atlas collection come out. And my favorite thing about that was that the Atlas has the drop boosters, which I think is super, super cool. So I need to get, I feel like Scott Manley and I were talking about this. I need to get him some of these. I need to send Scott some. He'll appreciate that. He really likes the drop boosters. Yeah, so we've made now 3 different rockets. Someday Starship will be on there, but meanwhile, I also definitely want to get, what I want to get out there. I want to get Baran and Space Shuttle and some other vehicles before we get to that. So let's see. From Ton to Tonk. Hey, Tim, what happened to the Spacewalk podcast? I missed it anyway. Great streams. The reality is no one was watching them or listening to them. Like, really not good. And I don't know. I feel like I pushed it for a while. And I'm one of those people, if we don't see like a growth in an area, or if it like plateaus, then I just don't get excited about it. And I just had no interest when like no one was watching or listening really to Spacewalk, which bummed me out. And so I kind of just lost interest. You know, if that had performed well and been worth the time and effort, I would have kept doing it. But I decided I might as well just put more effort into videos, which, by the way, I'm almost done with a new video. So that will be coming out hopefully the first bit of August. We'll have a new video, and hopefully you guys like it. It's a nice deep dive on grid fins, and specifically the grid fins on version 3, because they're quite unique. So we go into quite a bit of detail there. So is there something special about this launch? Are they trying to achieve a new milestone? So they're not really, to be honest, it's quite similar to almost all of the other recent Starship launches. I'm not going to like try to butter this up and be like, this is crazy, you don't want to miss this one. It's going to be super different, because frankly, it's the exact same thing. They're trying all of the milestones as Flight 12, except that they have even more. They have actual version 3 satellites, but they won't be going into orbit, so it doesn't really matter. However, again, integrating a real product, a real payload into a real rocket and seeing how they perform and make sure they don't have any glaring issues that are like, oh man, we didn't realize the vibration loads were this high. None of them worked, you know, like something like that before they, you know, bet the house on these version 3 satellites. That's kind of exciting. More cameras on even those. So we should get better imagery again of the outside of Starship when it's in space, which is really exciting. But that's the main thing, to be perfectly honest. Besides just like another launch from Pad 2, and hopefully we get a clean, boost back burn and a booster splashdown, a booster landing and splashdown. But as far as like what we expect to see, we expected those things in Flight 12 as well. We just didn't get them. So we are just under an hour, by the way. I didn't even notice. We flew through the 1 hour mark, and I didn't even notice. So thank you, Spencer, for letting me paying attention for me there. That's great news. So yeah, we in the next 8 minutes or so, we expect internally that the flight director will do the go no go poll, and here if we can show that the kind of the milestones. Now again, that's internal at this point. The go no go poll is for prop load. We don't hear that, but again, we normally get some kind of we like to hope that we'll get a confirmation from SpaceX online in regards to whether or not they're doing whether or not we're going, you know, into prop load for today, which is always a good sign. So yeah, that's what was the question? Yeah, that's about it. Hopefully we hear in the next few minutes though, in about 8 minutes, whether or not they are going for prop load. We'll lots of times see the visuals on the screen that they're going for prop load before that. We'll see some more serious tower venting, and we'll see some more tank farm activity as they're actually starting to prop load the vehicle. So this is From Virgil. I've noticed there is a short period of time when the rocket is in the upper atmosphere where the exhaust plume leaves a white trail. What is causing this? So it's just actually it's the exact same thing that causes that same phenomenon in planes, right? When airplanes are in the right conditions, right temperature and dew point and pressure, the external or the atmospheric pressure, you can basically do a flash condensation. So that's what's happening when planes, you see those big trails behind planes or jets specifically at altitude. It's the same thing with rockets, like just it's going through all of the conditions of the atmosphere within like a minute. So you're bound to, no matter what, hit a certain area where you're getting that flash condensation. And that's basically what's happening is something about the pressure system and the exhaust and the water droplets and the water in the exhaust, because that's what's coming out like a methane rocket. When you burn methane, you're just getting CO2 and water vapor. So it's turning into little clouds. And that's how we get rain. And that's how we sleep at night, with these precious clouds from the rockets. I have no idea. Something like that. I'll have to look into that more to give you a more gooder answer. From MPH 2007. Is it true that prop or LOX is flowed through the engine bells? If so, why do they not get frosty? Great question. It is. I have a video that I need you to watch called "Why Don't Rocket Engines Melt?" It talks about all the different ways that you can keep a rocket engine from melting and the different tactics that engineers use to keep a rocket engine from melting and to keep them cool. And so you have a few things, like you have, just literally a heat sink, make it a thick wall of a metal, and it will be able to handle a high temperature and, run the duration that it needs to run for 2 or 3 or 4 minutes. No big deal. It won't melt, and that's the most basic version. You have ablative, where you intentionally let it ablate away. You have film cooling, where you allow some exhaust and or extra propellant to just kind of line the walls to create a boundary layer to keep the nozzle from melting. But the most common in liquid rocket propellant, as far as like rockets go, not necessarily common in like smaller propulsion like reaction controls, but for like main engines and upper stage engines, the most common thing is to use regen cooling, which is literally where you flow propellant through the nozzles. You typically go down and then back up. You kind of do a turnaround, a U-turn at the very bottom of the nozzle, and that takes the heat out of the engine. It takes the heat out of the metal. The hardest part is the throat, is where it's the hottest, at the converging, diverging section of the nozzle, at the actual converging part. So, interesting. The clock is holding. We noticed. I did not notice that. Our clock is linked. We're just using the SpaceX website. So it is linked to that to be able to provide the T0 time. It's not going to be perfect, but that's where we pulled that data from. So, and it's frozen on the website. So it could be internal. They could be kind of just double checking some things before they get ready. Yeah, let's answer some more questions. Will the Starlink satellites completely vaporize on reentry? No pieces hit Earth. Correct. Starlink satellites are designed to be entirely demisable, 100% demisable, so that when you have 10,000 of them on orbit, as they go to their end of life, they will reenter and completely obliterate without any significant or massive structure hitting the ground. So that's intentional, and that is, but also where Starship's reentering, it's reentering in like this huge exclusion zone in the middle of the Indian Ocean, where it's like the absolute middle of nowhere. Like, it's intentionally the absolute middle of nowhere. So even if they didn't demise and even if they remained intact, then it wouldn't be a huge deal. When do I think they'll try for another booster catch? So this is actually a good question, because don't forget, the first time they went for a booster catch, they waited until they had a normal splashdown of the booster in the Gulf. And then they did kind of an edge case where they pushed it harder, and they might have done like an engine out situation before they did an actual booster catch. So I'm wondering if they'll do that same thing. If they will want to validate the edge cases before they bring the booster back to their multi-billion-dollar launch infrastructure, right? Will they want to do a splashdown today, a soft splashdown today? If that goes well, will they do an edge case where they, push it harder, do steeper reentry angles, and try to light the only land on 2 engines or whatever the edge case might be that they're trying to push. And if they do that, then Yeah, then I would expect for sure. Hopefully, if those things go well, I would expect booster catch by flight 15. Small chance though, if everything goes perfect today for flight 13, that they could maybe go for it for 14. But I would expect two that they want two validated booster performances before they risk it. But that's just kind of a guess. From Like a Boss Studio, I'm curious to see if a 3-stage Starship would work better. Basically, take a booster, add the hot staging ring to both ends, and stick it in the center of the current setup. Shorten 2 boosters, better ISP. So, no, the better thing to do would be basically to use the payload capacity of the upper stage. Let's say, actually, no, the best thing you could do would be throw away the upper stage, because then you could get 300 tons to orbit. And if you threw away, you get two. Sorry, let's say this as you can double the payload. Let's say this thing can do basically 100 tons to orbit right now today if they were to go for orbit. Then if you threw away the upper stage and didn't try any recovery efforts, you could get about 200. If you threw the booster away, you could do about 300. And don't forget, 300 tons to orbit is enough to literally launch two. Listen to this. This is important. This is how big this rocket is. If you expended both upper stages, you could take 2 Saturn V S4B upper stages, 2 lunar landers, 2 command and service modules, and launch both of them into low Earth orbit, where they could then go on to do a full moon mission. That's crazy. You can. Oh, is the clock moving again? No. Yeah. Okay, cool. Clock is moving again. That's exciting. We like to see that. All right. So hopefully that's good news for today. So yeah, that's the best way you could increase the performance, would just be expending stuff. But obviously that's not the cheapest. That's why they're going to try and do reuse, is because first off, who needs 300 tons to low Earth orbit? That's already crazy. But second off, it's cheaper. You know, if you're having to throw away hundreds of millions of dollars of hardware versus spending $5 million on propellant, obviously that will eventually win out. It's just the cheaper thing. So a 3-stage version, though, you'd probably pretty quickly start expending hardware. And you wouldn't necessarily, believe it or not, staging costs, you know, it has payload penalties. You have stage separations, you have dead, you know, tankage areas, you have other considerations. 3 stages doesn't always just simply make for a better rocket. Yeah. But that is a good question. I like that question. I'm trying to think of, you'd have to run a lot of tables of things. Tim Havens Jr., thank you for becoming a member. You're awesome. This is from Forge Gamer in our Discord. Thank you, Forge, for being in our Discord. If you want to be in our Discord community, you can do that through Patreon, patreon.com/everydayastronaut. We have an awesome community. I love seeing everyone checking in here today. But Forge Gamer asks how I'm doing today. I'm doing really good. I'm doing great. I'm happy. I know I'm not on site today, which is a bummer. I am planning for sure, like, no matter what, is I'll be there for the first, for sure, the first ship catch and hopefully the first booster catch. Those might be the same mission. I guess we'll have to wait and see. But no, I've been good. I've been traveling a lot. My family went on a European vacation for my parents' 50th anniversary, and it was amazing. My entire family. It was really great. By the way, we see Big Tower Vent. Big Tower Vent is great. See that huge? That's good news that they're really conditioning for preloading. So that is great. Yeah, I'm good. And then this week, last weekend was Open Sauce, which I was in San Francisco for Open Sauce. And then, which was amazing. That's one of my favorite events of the year. That and Astro Awards, which hopefully we'll have some announcements in the next month or two as we continue to plan for Astro Awards. But the cool thing is, what was I saying? Oh, yeah. And then this week normally is always Ragbri, which is like this big, giant cycling trip across the state of Iowa, which is where I live. And it's one of my favorite things to do. But I was so exhausted from traveling for like 3 weeks straight that I ended up being able to do the day yesterday. And I was only able to do that because it scrubbed yesterday, basically. So I enjoyed yesterday and we only did 57 miles. So like 90 kilometers. Nothing, right? Except that I'm dying because I haven't biked this year. Take a chance, 2356. So is this just a repeat of 12 minus the panels? Minus the panels. Does anyone remember what the panels were, Spencer? Do you remember panels? I don't know what minus the panels are. Yeah, I don't remember panels, and I can't think of if that what that would be a misspelling of either. Minus the pandas, maybe. Maybe they meant pandas. Were there pandas on flight 12? I don't quite remember. Yeah, maybe the Dodger dogs, but they had those minus the panels. I don't know. Anyway, it's basically exactly a repeat of Flight 12, just with more realer satellites, and yeah, and some, they tweaked the boost back burn sequence, and hopefully that's more reliable this time. Yeah, that's really about it. From Drac Richards, pointy end up flaming and down check, please. Oh yeah, and also Forge Gamer asked for that. Sorry. I probably should do that. We have two great shots here. With my trained eye, my years of doing this, I can confirm that the pointy end is up on this rocket and the flaming end is down. Mostly using that left shot to confirm that. They did not install it backwards this time, which I'm always a big fan of. From Noah Ronaldo, hi everybody, astronaut, good to see you again. I was a little shocked that we had an abort at ignition. I wonder what caused the 4 engines to not ignite. Like I said, there's kind of been rumors on why those might not have ignited. I don't want to spread rumors. I hope they have it figured out, because we're about to find out here today whether or not that was indeed fixed and addressed. I don't know, actually, to be totally sincere with you. I don't know what the exact root cause of the 4 engines not lighting. If anything did come out, then yeah, let me know. Does it ever confirm that the spin was intentional? The spin. Oh yeah, no, it was not. He's talking about the landing burn of the ship did like a pirouette. It was never confirmed that was intentional, but it's kind of considered to be. We think that was intended, especially because they've landed like a lot of ships softly and straight. I think they wanted to do that to ensure that they got imagery of the entire heat shield, no matter what. So, yeah, but never confirmed, never officially confirmed, just heavily speculated on. Low IQ Spacey Man. Genuine question: if you had to be brutally honest about Starship HLS, logistically speaking, do you think we'll see Starship HLS to be ready in time for Artemis landing before 2030? Look, I'm just like any of you. And if you're anything like me, you have ebbs and flows of this stuff. You have excitement, followed by not excitement. You have cynicism, and then some optimism. You have a lot of that stuff, and literally depending on the week for me, that question changes. 2030 is going to be hard. The hard part, though, the hardest part about this is to predict when this rocket and this program goes from this big giant experiment, the flattest part of the curve. When you're looking at exponentials and you look back at them, there's like a long time where it's nothing, where it looks flat, but that's the exponential part, and eventually all of a sudden it just goes whoop. And to predict when it goes whoop is extremely hard to do. And in hindsight, it's always obvious. It's always like, oh, well, that's because look at this happened and they figured this, and then the next thing you know, done. Starship is big. It's ambitious. It's the biggest, most ambitious rocket to ever fly, like objectively speaking. And they're trying to do things that have never been accomplished before. They have a lot of things that they have to prove out, like orbital refueling and rapid reuse. Even if they don't do rapid reuse, let's say it takes them 1 month to refurbish a Starship before the next flight, or a booster. Let's say it sticks to Falcon 9 timeframes. Well, the cool thing about having a place like Starbase and the factory, and not only in Texas but also in Florida that they're working on, is that you don't need to have rapid reuse. You can actually, if you have a big enough fleet, you can still be flying like once a day. You can be flying multiple times a day when you have multiple launch pads. They're working on 5 launch pads. 5 pads are currently under construction right now, almost 6 really, if you think about it. And so, if you have enough pads and enough vehicles, you can still fly an extremely rapid cadence. So hard to tell right now. Really hard to tell if, I think the next year will be telling. If by next summer, if in 1 year from right now, let's say July 31st, 2027, if we've not seen an orbital flight of Starship, I'll be very concerned that we aren't going to be landing anything Starship related in 2030. If by the end of the year we have an orbital test flight and we start to see orbital refueling tests like on the horizon, I think things will look a lot better. I think I'll have a lot more confidence that hey, they're putting the pieces together now. But it's hard. It's really hard to tell. This should not be in any way, shape, or form advice on what's it called, investments or stocks, because none of that matters. None of that matters to me. I think that's all a bunch of stuff that I could care less about, especially when it's tied into all these millions of other things. I don't care. I care about hardware. I care about rockets. I care about progress. I care about space exploration. So those are my thoughts and opinions. I still think HLS at this point, from what we've seen of it, is extremely complicated. I would love if they made a lighter weight version, like, carbon fiber version that's dedicated for that. That's multi-stage with the descent and ascent stage and hypergolic. Like those would make it like so much easier, at least in the short term. Later on, they can pursue the bigger ones. Let's see here. How many iterations, and this is from one Armendro, versions of Starship do you think it'll take to be certified for human flight? Man, I don't know when humans will be flying on ascent, like from the ground without any kind of abort system on Starship. I don't know. I have no sense of when that could or should be, or if. I don't know. A long ways away. But as far as once it's in space, if you wanted to have, a space station, based on it and dock up to it or land, like with HLS, I think that's reasonable within the next 4 years. I think that's reasonable. Freak 5837. Am I going to start incorporating cowbell in my music? Yeah, I definitely need more cowbell. I've got a fever and I should for sure be doing that. What was I doing? I released a whole album that didn't have any cowbell in it. It's not good. 01 Vladdy 01. The spin at the end of Flight 12 is great for photos in the heat shield, but was it planned or did it? Yeah, so I kind of answered that. Never confirmed, but I feel like it was planned based on how we've seen other ones perform, and the fact that the engines clearly did like a split to induce a spin felt very intentional. Can I see the launch if I'm in Grenada, which is off the coast of Venezuela? No, you cannot. I don't think there's any chance of that right now. Yeah, you have to be quite a bit further north, I think, than Venezuela to be able to. Let me look. Let me not speak out of my butt. Let me pull up Google Maps, see the approximate Venezuela. Oh, I forget Venezuela's at the very You're right next to Colombia. And Grenada, in fact. So the hard part for you is hello mother, hello father, here I am in Camp Grenada. Oh, dang, you're way okay. You might very well be able to see this. The hardest part for you, sorry. This is why I don't talk out of my butt all the time. See this? I'm fact checking myself on the spot. You're really close to the flight path. If the lighting conditions are correct, you would be able to see it fly over. And in fact, it is flying east, of course, from there, as we know. Depending on what time sunset in Grenada today will be at 6:35. Grenada, is that right? Yeah, I guess like 6. Okay, so yeah, you might actually catch it because it'll be dark where you are, and if it's still glinting off the sun, which it should, you actually might get a really good view of it. That's crazy. I would have full on said no, and I did say no, and I have to immediately take that back. Cool. I think you will see it potentially if you know where to look. So from stage cutoff, just start looking north and look for a big bright star, basically. Let's see. I'm still paying attention here to the tower event. The next thing we'll look for, by the way, kind of milestone wise, why don't we throw up those milestones? We will have at T, like just under T40, what is it, T37, 30. Yeah, so around T40 or so, a few minutes before that ship locks loading start, we will see the tower vent, that big white cloud coming off the tower. we will see that stop. So right now they're cooling it down, preparing it for the cryogenic fluid, or liquid oxygen, and right, specifically that one's liquid oxygen, but also there's a liquid methane pipe going up that tower that will load it into the ship. And you can see the little arm sticking out from the middle of the tower that connects to the upper stage. That's where the quick disconnect is. That connects and fills up the ship from those two ports. And then at liftoff, disconnects quickly, hence quick disconnect, and swings away from the vehicle so it doesn't get damaged as the 33 Raptor engines are about to fly in very close proximity to it. So, that's what we're looking for. So hopefully we'll see that tower vent shut off here relatively soon. And hopefully we will start to see the first signs that the ship is prop loading, and that will be good signs for today's launch. Always like to see that. From Andy B 632, hi Tim, unrelated to Starship, but who's your favorite Apollo era astronaut? Well, I've now met Charlie Duke and had conversations with him, so he's probably up there with my favorites. But he's also he's such a great guy. Like if you listen to any of his talks and stuff, he's awesome. I have a talk that he did at Astro Awards 2 years ago. He's awesome. I also have always really liked John Young. I thought he was hilarious and great. Those are probably my two favorite Apollo era astronauts. I'm probably forgetting someone even more important. But John Young was awesome for sure. So, yeah. From Olaf, how you doing? Do you think there already are tankers and or depot starships somewhere inside Star Factory? We should expect tests with those in the near future, around 17 or so. All depends. I think they definitely have hardware kind of working on it. The cool thing is, like, a tanker, specifically, like a tanker is basically just a normal starship, but with ports. And we're basically seeing like half of the hardware for that as we speak. Literally, those two like knob things next to those vertical rails are the docking ports, are 2 out of the 4 docking ports. And to do fuel transfer, there'll likely just be internal plumbing on those that we will hopefully see at any point, basically. That's the physical manufacturing of a depot, of a tanker is very similar to what's flying now. So I don't think we'll see much difference there because those will re-enter and will land. By the way, notice that the tower vent is dying down. That's good. And we will likely see that cut off here in the next few minutes. But as far as a depot, that one will be weird because you'll see something with like no heat shielding on it. We'll see no flaps on it. And it might be slightly different dimensions. So I'm excited to see that. They have those windows outside of Starbase, and some keen-eyed photographers and stuff will hopefully get little snippets when we start seeing that kind of hardware floating around. But I would expect that to be in the next year for sure. Oh, hold on. Space Monkey app. Launch visibility map. Yeah, that'd be the launch portions. I'm looking at this here in Discord. Yeah, it'd be a little while for it, but it does fly like right over Venezuela. So Venezuela is in a good spot to see it, looking like almost straight north. What's today's mission objective? Same thing as Flight 12. Same thing as almost all the other ones. Have a clean ascent, a clean boost back and landing burn on the booster, and a clean deployment of 20 version 3 satellites that are currently stacked inside the upper stage, a Raptor relight test, and then safe reentry and splashdown. Whoa, I don't know. That flash through there, that looks spooky for 1 second for some reason. I don't know if I just caught that out of the corner of my eye. Funny. How many hold down clamps and how do they work? If I remember, it's 20. How do they work? Watch CSI Starbase. CSI Starbase on YouTube or X. He has insanely deep dives on the pad and on the stage 0, they call it. I'm not going to really even comment further because I will do it so much of an injustice compared to anything that Zach Golden does on the topic, because that is his like bread and butter. I like to be kind of an engine guy and an overall like rockets guy, and he is the pad 0 guy. So if you have any questions about that, watch his videos. You will certainly have more than your curiosity scratched. So real quick, I wanted to get ahead. I saw we had a big super chat from C-Angle 4394. I'll help with tacos tonight. Thank you for all your coverage as always, Tim. Well, thank you so much. Really, really appreciate the generous support. So everyone say thank you. And it looks like we have Jack Byer. Hi, Jack. Miss you. Hopefully see you really soon. $10 super chat. Thank you, Jack. Love you. And thank you for the support. Get out there and mine some asteroids, though. Come on. Get to work. Get those asteroids back on Earth. Get us some of those precious metals. Make a necklace out of those precious metals. I don't know. I don't know why I'm talking like that. Can you congratulate me and my finance, Kim, on our engagement? Absolutely, I can. Brandon and Kim, congratulations on your engagement. Everyone say congratulations, Brandon and Kim. That's great. Let's see here. This is from Juju Junk. Do I think other countries will join the race back to the moon in a boots on the ground fashion? And when do you think humans will step foot back on the moon? Well, I mean, China is the main person. I hear music right now, Spencer. Do you hear that? Is that something coming through? Like really clearly, actually. Are you guys hearing the music? I don't know where that was coming from. That was weird. It was like FM noise almost. Sometimes if you have a big cable, like a high gain cable coiled up like an XLR, and you have it gained up really high, sometimes you can hear literally like you can pick up FM radio, and it's really funny. I don't know if that was it. I don't hear it anymore. No, I don't know if we just muted the pad or what, and if it's just something on my end. But I don't know if you guys did not hear music. Okay. They did. People heard it too. Okay. It might have been going out on the. I mean, I don't think it was anything besides just like static noise, but funny. They heard it too. We don't know what that was. It was ghost music. That's the only explanation. All that white stuff out there on the pad is clearly ghosts. It's clearly ghosts playing music, swimming around our mics, going, woo. So by the way, we're really close here. We should be seeing prop load beginning on Starship upper stage. Unfortunately, our one kind of tight camera isn't going to be showing that right now. But boy, with how active that tank farm is, you can tell they're getting ready for all stars to stuff like copyright music. Let's see here. A boat passed by. No way. It was a boat driving past one of our sets of mics. That's hilarious. Well, there we go. Or ghosts. Or ghosts. We'll go with both. Maybe it was ghosts on a boat. In my opinion, and optimism, we'll see people back on the moon before the end of this decade. It's going to be close. I think we're within, like, before the end of the decade, it would be December 31st, 2029. I kind of have to almost say no to that one. But if we're saying 2030 counts, which it doesn't count as the end of the decade, I wouldn't be surprised if we see people land on the moon again in 2030. It's kind of my current gut feeling. Wouldn't be surprised me if it goes to 2031 or 32. But hopefully sooner rather than later, we'll see. From Christian, now that SpaceX is public, how does that change things, or does it change anything? To be perfectly honest, if you've followed anything with like Elon and Tesla in the past, they pretty much seem to do whatever Elon wants and whatever the executives want, and don't seem to care that the public aspect didn't seem to change that company too much. And I will kind of say it very clearly seems to be the same thing for Starship and for SpaceX. Very feels like they got their marching orders of what to do, and they're head down going towards that. And I don't think the fact that they're a publicly traded company really will be changing that too much. I won't answer too much more on that kind of stuff, just because like I said, I don't really care about the financing part of things. SpaceX is about to go live here soon. Before they do that, I did want to remind you guys that if you're on our email list for our web store, we have had a 20% off thing right now. A 20% off. What's that called? Sale. That's what it's called. 20% off of, because it's the Apollo anniversary, the anniversary of Apollo 11, and so that ends today, because we did the 7 days of the mission from July. What is wrong with me? From July 16th through July 24th, we have this sale. So ending tonight at midnight, all of these things that are 20% off, including our 1969 collection, as well as our Translunar Coast collection, are 20% off. So get some amazing merch for yourself. everydayastronaut.com/shop. Support the channel if you want. I'm wearing this shirt, which I love, the Orange to the Core shirt. I love it because it is a nod to the orange core of SLS rocket. It's the isocyanates that make the core orange. And I just think this is a fun, really cute shirt. I wear it far too often. So if you want to support the work we do, head on over to everydayastronaut.com/shop. Get 20% off right now without a coupon code. It's just all right there. Bingo, bango, bongo. I'll accept those. I don't care. And yeah, including our button-up shirts. I think people always forget that not only do we have short sleeve button-up shirts, which the European brain cannot comprehend a short sleeve button-up shirt. Long sleeve button-ups for you Europeans and fancy people out there. Here you go. We have those as well. So and these have little Apollo lunar landers on them, which makes them really cool. As you can see, some people might think they're like a small bug, but those nerds of us, we know what's up. There you go. everydayastronaut.com/shop. Get something while it's 20% off. And that's all I'll probably say about that for now, because we're getting close here to the official SpaceX stream starting at T-minus about 30 minutes or so. Actually, they're starting to go live here now. Is that right? Is that what I'm seeing? I will get back to answering your questions. Again, sorry if I missed some super chats. Oh my gosh, my queue is way longer than I thought. No, I talked too long. I just simply talk too long. I talk too much. Like I said, during this section, when SpaceX is hosting the official stream, I'll basically be shutting up. I like to be a passenger. I like to listen along. And at that point, obviously, they're going to know a lot more than I do. But then stick around with me as well. During the coast phase, there's a lot of time to answer questions. Hopefully, I can get caught up on our queue. And yeah, we'll have this going, the whole time, so you can see. You won't miss a thing. If you stay with us, you won't miss anything. So yeah, we're gonna listen in here as soon as the little intro thing's done, and as soon as the copyright music. We might have to duck out stuff sometimes when copyright music comes in, so we don't get copyright strikes. But thank you so much for watching with us. We hopefully will be bringing you the highest quality footage there is right now available on YouTube. And I love you guys, so thank you for watching with me. It really does mean a lot. It means a lot to our team. So we're in. Let's listen.
5:19 p.m. Texas time, and we are just over 31 and a half minutes away from Starship Flight 13, the second test flight of our next generation Starship, version 3. During our initial launch attempt last week, we had a clean countdown, loaded all propellant, and got all the way to engine ignition, where the vehicle executed a safe shutdown when its automated systems detected off-nominal startup on 4 engines. That safe shutdown ensured that both the vehicle and launch pad were kept safe. As we often say, the payload on these test flights is data, and even when we don't get off the ground, we learn some valuable lessons and improve from them. We're going to dig into the details of that in just a moment, but all of that to say is that we're here today and we're ready for our second launch attempt. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Nathan Commissary, a civil engineer here at SpaceX. Today we're coming to you live once again from just outside the Star Factory production floor, about 1.5 miles from the rocket on the pad.
Back in May, the first test flight of Starship version 3 delivered tons of data, and we'll be putting those learnings into practice today on Flight 2. All of this brings us one step closer to a fully and rapidly reusable vehicle, the key to enabling frequent flights to the Moon and Mars. Starship will also enhance Starlink's constellation and connectivity on Earth, the Moon, and beyond, while helping establish a network of AI data centers in space. Success on today's sub-orbital mission also opens the door for near-future orbital flights and our first attempt to catch ship on Tower 2 here at Starbase.
And this is an exciting day for the Starlink team as well, as we're planning to deploy 20 of the newest generation Starlink satellites. These sats aren't intended for operational use and will only be in space for about 20 minutes before demising. But during those 20 minutes, we're going to attempt to speedrun a bunch of tests. Things like deploying solar arrays, firing thrusters. We'll get into those a little bit later into the show.
Yeah, and what Starlink engineers learned today will be essential to deploying operational V3 satellites into the Starlink constellation on future Starship flights. These larger, more powerful next-generation satellites are designed to boost orbital capacity, strengthen the overall network, and deliver a noticeably better experience for our customers.
And as we've said before, Starship is a developmental program. What we're doing today is a test. We test in flight because it's the best way to rapidly iterate the design, and it's the best way to put the vehicle through its paces in the actual conditions it will experience during an operational mission.
Yeah, exactly. So while we have real Starlink satellites on board, the most important payload today is data. But no matter the outcome of today's test flight, excitement is once again guaranteed.
Now let's head a couple of floors upstairs where Dan Hewitt is just outside the Launch Control Center. How's it going, Dan?
Hey, Nate. It is going great. Hi to you and Kate. Hello, everybody else. I'm Dan Hewitt with SpaceX Communications. Happy to be here with you for another launch day. As Kate noted, our first attempt to launch this flight test last Thursday ended early in a pad abort. Let's dig into that a little bit. So 4 of Super Heavy's 33 Raptor engines aborted at startup due to issues with their aux turbo pumps. Those rapidly pressurize and feed liquid oxygen into the engine for combustion. Those of you that like to pay real close attention to the on-screen telemetry, you saw this at T0 during that first attempt. We command the engines to start up simultaneously. You get some slight differences as the engine adapts in real time, but you saw 4 not light up. So 4 out of 33, what exactly happened? We have a launch constraint built in where we can only be down 2 Raptor engines at liftoff. So the vehicle detected more than that, we're out. Automatically aborted before the final T0, safely shut down all of the engines that started up. We dug through the data, and what we saw was some off-nominal spin response in the aux turbo pumps on 6 of the engines. So the most likely root cause was determined. We were collecting some moisture inside of the pumps from previous operations, which then froze when we introduced that cryogenic propellant, and that either slowed those pumps down or stopped them completely from spinning. So for this
I see that you guys are saying there sounds to be something doubling or something. I'm not hearing in our program. I'm not know what's happening, but we are working on it. It might be something that doubled on our end somewhere. So thank you for pointing it out. But I want to listen in here still to and all.
Those engines off, as we said. We tested one on a test stand up at McGregor, helped screen for any other issues that might be hiding, and that one was actually able to do a full booster ascent burn. So got us in a good position for today. Even though we didn't get off the pad last week, we learned about the engines, the prop systems, how they perform in the flight environment. Already going to drive some changes to make Starship more reliable. We also got a real-world test of an abort that's designed to take place at one of the most critical dynamic phases of flight. We safely shut down 29 running Raptor engines, safeguarded the vehicle and the pad. A mountain of work goes into designing aborts. You've got software, hardware engineers just dreaming up bad day scenarios, how we want the vehicle to respond, just to give us the best possible path to maximize safety, preserve the mission and the hardware, so we're able to do that. All right, that was then. This is now Flight 13's second attempt. So things are looking really good at the moment. Just behind me here is the Launch Control Center. Everybody's on console, looking at the systems on board the vehicle and on the pad as we count down to liftoff. Propellant load is underway. We slipped a little bit into our window as we waited for some last couple of things to settle out, and we are targeting a liftoff at 5:51 p.m. Central Time. Weather today, you can see we've got blue skies. We're going to do a little weather corner here for a second because we were originally attempting to fly yesterday, and we didn't because of, we said, weather. I want to be clear, the cause of not flying was visibility. It had nothing to do with launch weather constraints. One of the key goals of this flight is to get very clear imagery of the tiles on Starship as we're flying it at a higher dynamic pressure. You can't do that when you have clouds completely obscuring your view through all of those critical phases of ascent. We're actually capable and legally allowed to launch into lightning because we've done a ton of testing, unique testing, analysis, studying aircraft capabilities, and it's designed because that's ultimately the cadence we want to fly at, like an airplane. We're going to utilize that new capability carefully, but we're very aware if we want to fly Starship as often as you could fly an airplane, you're going to have to fly in weather that historically would keep rockets on the ground. So we're doing that analysis, we're doing that testing to prepare for the future. Aside from weather, we're watching the range both in the Gulf right here off Starbase and in the Indian Ocean. That's currently green. And we're not tracking any vehicle or pad issues that will preclude a launch today. Speaking of the pad, that launch infrastructure it's every bit as complicated as the rocket itself. It's designed to operate in some of the most extreme conditions on Earth. In case you missed it, we had some pretty cool insight into what it takes to launch the most powerful rocket on the planet in the second episode of our ongoing documentary, Starship.
Just a quick little heads up. Obviously, we know about the audio issues, but apparently a lot of the audio issue is actually on SpaceX's end. Specifically with Dan's mic, had like this really hollow, thin sound to it. But we also had something that happened for a little bit at the same time. So it was actually really hard to track down. Things like muting my end, it doesn't matter. I'm wearing headphones. It wasn't like I know it probably sounded to you guys like it was picking up through my mic, and that was not the case. But I heard something in there that was one of the most interesting things I've really ever heard from this program so far, is that they have, certified themselves, or been, not necessarily themselves, but they've certified to be able to fly through lightning, which is something crazy. There's a whole thing called the lightning commit criteria, where basically what happened, it was in, what was it, like 1988 or 1993, one of the somewhere around there. I did a whole video about this, about the range of a rocket, and they basically avoid flying through lightning because it can fry electronics, obviously. But if you design around that, you should be able to fly through a lot of weather conditions that would typically scrub a rocket. So hearing them say yesterday got scrubbed, not because of the weather, but specifically because of visibility, was actually really unique. I had not really heard that nor fully considered that, which is really, really cool. By the way, if you are missing what you're hearing on screen right now, again, we kind of duck things out for copyright potential, but this is all posted in a really good video that I highly recommend you guys watch on SpaceX's YouTube channel, or on their main website, just spacex.com. They've this is episode 2 of like this really cool documentary about about Starship and about how they're making this whole thing work. And you see so many good like behind the scenes clips and really unique, interesting things. Now, sadly, I didn't hear the exact reason why the 4 engines didn't start up properly. That makes me a little sad, because we're talking about sound problems, but hopefully we'll figure that out. Or if anyone did hear what exactly, it was something like water or ice had gotten into the 4, which would confirm those rumors. So let's see here. Real quick, shout out to one of our mods, Daniel. Thoughts on newly released concept for Artemis 3 with Starship? I haven't seen anything brand new. Can you drop that in Discord, Daniel? I don't know if I've seen anything that's new or different. I have not really been online since yesterday, so let me know if I missed it. And hopefully we'll hear we're still working on where to do Astro Awards next year, and when. We're likely pushing it later into the year to deconflict with with things like the holidays, and just make sure we have nicer weather and an easier place to fly in and out of. So they didn't start based on the oxygen. Ox heads have heard that. So bad Pistons. By the way, hang on, I saw a really funny comment that I just have to razz you back a little bit. Someone goes, "This audio is unwatchable," which audio is unwatchable. I just thought that was funny. I understand. Actually, a good friend of ours, a good friend of the show that did like 400 SpaceX streams, has a famous quote of saying, as Jamie Higginbotham, she said, video is 90% audio, because people can forgive bad video quality, but they can't forgive bad audio quality, which is really scary, especially when we're trying to do all these things remotely. Yeah, I always thought that was interesting. 6+ years and happy to keep supporting you. Thank you so much to John. Really greatly appreciate it. 83 months from Rainier. Greetings from Germany. Hopefully we'll see a good and complete mission today. That's got to be about as high as anyone has been a member. Amazing. When will Starship launch from the Cape? Well, hopefully by the end of the year. I mean, we're looking like, the Cape is looking pretty good. They're making great progress out there. And we might see a Starship launch before the end of the year. Okay, let's listen back in. It sounds like they are back on air.
Right, and just hear all the exciting stories of how we tackle these problems out here in Starbase. Super exciting.
Yeah, and by the way, if that looks like fun to you, come join our team. We are seeking scrappy problem solvers to help us build the future. Okay, let's go meet the rocket out on the pad, Starship version 3. It's the most powerful rocket ever developed and ever flown.
And it's also the tallest at just over 407 feet tall, fully stacked. It is massive. Standing at the base and looking up is like looking up at a 40-story building. Incredible.
Yes, it's a two-stage rocket. Both stages are designed to return to Earth and fly again, making that thing that you see on your screen the first fully reusable rocket ever. The bottom half, the first stage, is the Super Heavy booster. That's the silver part. It's powered by 33 of our newest iteration, you see them there on your screen now, Raptor 3 engines. They run on liquid methane and oxygen, and this version of Raptor provides a significant increase in thrust. With that additional thrust, as you can see here by these comparisons, the version that we're launching today, version 3 on the far right, that version of Starship off the pad much faster than our previous versions. The one on the far left is, I believe, is actually our Flight 1 footage, and in comparison, they really go.
Yep. And now Super Heavy has 3 grid fins, which you can think of as aerodynamic rudders. You see them on your screen now. They steer during landing. They're 50% larger than on previous booster versions and are designed to support rapid use and a more stable atmospheric re-entry.
I love that shot there. And at the top of the booster, we've got the hot stage adapter. It's designed to protect the booster during separation, and now it's fully integrated for reusability.
And stacked right above that is our upper stage of the rocket, or stage 2. It's what we call Ship. It's powered by 6 Raptor engines, 3 optimized sea level performance, and 3 for the vacuum of space.
Ship's design could one day enable point-to-point transfer on Earth, meaning you could travel anywhere on the planet in an hour or less. Sounds pretty great.
Sounds awesome.
It's designed to carry massive orbital cargo and crew to Earth orbit, the Moon, Mars, and beyond.
And for the first time, we are carrying real Starlink V3 satellites to space. For more on that, let's head out to California, where Tyler is standing by with the team in Hawthorne. How's it going, Tyler?
We are working on a backup different audio thing because we're decoding the official X stream, and it might be our decoder. We are trying to work on that to see if it's a better solution to just pull it in through OBS and see if that's better to pull into our truck. I will let you know if that is better, and you might see a little bit of a transition here, but meanwhile, we'll keep listening in. Sorry, I know it's not ideal, but I do appreciate you watching with us.
And power generation. So we'll be adding around 20 times the capacity into the constellation on each Starship mission as compared to the version 2 satellites that we launch on Falcon. And that means that we'll be able to serve more people all around the world and with increasingly better high-speed internet. Like all Starlink satellites, the V3s are built at Starlink's site in Redmond, Washington, where we already build more satellites than anyone else in the world today. Now, the V3 sats are designed to support 1 terabit per second of downlink and 160 gigabits per second of uplink capacity. That's approximately a 10 times improvement in downlink capacity and around a 22 times increase in uplink capacity from the version 2 Starlink satellite. Serving this capacity to and from customers are the satellite's upgraded phased array antennas. The upgraded phased arrays are fed by SpaceX's in-house developed chips that were designed to serve customers more efficiently in both densely and sparsely populated regions simultaneously. And each Starlink V3 satellite is also equipped with 6 high-capacity 400 gigabit space lasers. Now, these 6 lasers will allow high-bandwidth traffic to flow uninterrupted between any 2 points in the world with redundant paths across a petabit laser mesh network. And if that wasn't enough, the V3 will carry 4 quad-band radio frequency backhaul antennas. And these will take advantage of the Ka, E, supported capacity compared to the V2 sats. And that's a lot of growth in capacity and capability. And as such, the new satellite design requires more power. So the solar arrays on V3 will generate approximately twice as much power as the current arrays that we fly on the V2 satellites. And they're also optimized to reduce drag in the lower orbital altitudes in which these new satellites will operate. But before we operationalize these satellites, we want to put them in a flight-like environment. These satellites were loaded into Starship last week ahead of that first attempt. And once deployed, the Starlink team will only have about 20 minutes of flight to speed run some of these tests before the sats demise in the atmosphere. The team will attempt to run tests such as extending the new solar arrays and antennas, connecting with ground stations, and turning on the satellite's communication systems. And this is all part of SpaceX's iterative process to technology advancement. From the very beginning, Starlink was designed to scale rapidly and improve continuously. From production to launch and ground infrastructure, Starlink is uniquely positioned to keep pace with rising demand around the world. In fact, just last week, we rolled out the next generation Starlink kit, the V5, which is built for reliable, high-speed home internet.
All right, here comes the copyright strike, so I'm going to go ahead and talk over it. Yeah, new Starlinks, always a good thing. And again, thank you guys for sticking around, because we did get the audio fixed up just by switching to OBS, which is normally never the solution. And someone said, like, you should soak test. We tested all day yesterday. We tested all day today. And of course, these things only tend to pop up when you absolutely are on air and only on air. It's so weird. We have this whole setup out there it's been out there for 9 days now, and thought we had everything all figured out this time, but there's always going to be something that bites us in the butt. What's my favorite? Thank you so much from Macho Taco. What's your favorite space moment or memory? The ones that you and the one that you look forward to in the near future. Oh, hang on, they're already talking again. So I'm going to have to save that for later on.
Director of Satellite Engineering, Ian Dahl. We covered a whole bunch of stuff, really focused on what are the 3 limiting factors to making data centers in space a reality. First one we talked about was mass to orbit. That's where Starship comes in. We're going to need megatons into low Earth orbit, and we're going to be combining its full reusability and the really big payload capacity to launch the number of satellites that we're talking about, because we plan to deploy up to 1 million AI satellites, and those are going to function as those orbital data centers using Starship for the high volume, low cost launches. A couple of really key reasons why moving data centers to space has advantages over building them here on Earth, which gets into our second limiting factor, which is power generation. It's always sunny in space. Satellites can harness that sun, that near constant solar energy, which is really going to be the only way to scale if AI continues to grow at the pace that we see, especially when you contrast it with all of the challenges that you have here on Earth. Within about 2 to 3 years, we believe space-based AI compute is going to become the lowest cost option as those launch costs continue to drop and Earth-based constraints continue to grow. It's going to just transform how Earth powers AI, unlocks the future. And then our third limiting factor that we got to go figure out is going to be chips, and we got to do that fast. And that's what we're doing with TerraFab. That's going to be the most epic chip building effort ever, not just churning out really cool advanced chips, but also building a massive scale location to do it. We're talking 100 million square feet, so about 10.
We've kind of been seeing this already the last couple of times, so I wanted to kind of talk about my opinions on a little bit of this stuff, because obviously there's a lot of people that don't believe in AI data centers in space, or just believe in AI in general. I'm definitely one of those people that I don't want the positive aspects of a tool like AI or large language models to outweigh, to impact people's lives, to impact communities that are dealing with noise and power issues and rising costs. And actually, that's, I think, forget the cost, like the dollar per compute power. I actually think just simply the fact that we can get these compute into space, get compute on orbit, if we can do it even remotely close to the same price as building out AI data centers on Earth, I think it's worth it, just so we don't have those impacts on Earth, the impacts to again, local communities and just all of those extra things. There's a lot of complications in building these massive data centers all around our planet, and honestly, I think that's probably one of the best uses of spaceflight is get that stuff that we don't want here on Earth out there. I remember in 2018, Jeff Bezos had this talk about how he thinks that Earth should become a sanctuary, and we should do all of the industrial scale stuff in space. And I think that's kind of what they're aiming for, and I'm a supporter of that, because So like I said, the flight profile is almost the exact same as Flight 12, but we'll listen in here because they're talking about it.
Starlink V3 satellites. We also plan to relight a single Raptor engine. Re-entry is just a few minutes later, which should provide some amazing views thanks to Starlink. And typically, we see some pretty fantastic views of the ship's blistering re-entry through the Earth's atmosphere. A plasma blanket will form around the vehicle and never prevails to provide epic scenes. And lastly, we'll conclude today's test with a landing flip, a landing burn, and a splashdown in the Indian Ocean. And with that, let's kick it over to Dan for a countdown update.
Thanks, Kate. Good news. We just heard from the flight director. We are T-minus 10 minutes. We're a little bit past that now, not tracking any issues for launch today. Range continues to be green. Our range team hard at work, making sure we're clear out in the Gulf and in the Indian Ocean where we're going to be sending the Starship. Weather continues to be gorgeous. Again, no clouds. We scrubbed our attempt yesterday, or didn't even try yesterday because we had such poor visibility. Weren't going to be able to see those tiles on the way up. That's a key kind of experiment objective for this flight today. And so we're looking really good with weather today. In the future, we'll see what kind of adverse weather we can fly into. We are capable and allowed to launch into lightning, but we're going to utilize that new capability carefully as we eventually continue to evolve Starship to fly it at an airplane-like cadence. You can see the prop load there on your screen. We're just about closed out on the main tanks on the ship. We just started propellant load in the header tanks on Starship. Those are the two smaller ones up top that we'll hopefully be using for the in-space burn and a landing burn at the end of its mission. We started loading our propellant at about T-minus 35 minutes today, and we're going to continue all the way down until we're inside 3 minutes to launch. We'll close out at about T-minus 2 minutes and 50 seconds on booster, and then 2 minutes and 10 seconds on the ship. So at the moment, we're looking good. That launch time, 5:51 p.m. Central, a couple of minutes into our window today. So we'll be back real soon. Toss it back down to Kate and Nate.
Thanks, Dan. Recently, NASA announced the astronauts for the upcoming Artemis 3 mission. The Artemis 3 mission is a crewed demonstration mission in low Earth orbit designed to demonstrate critical systems needed for future lunar landings. Astronauts Andre Douglas, Luca Parmitano, Randy Bresnik, and Frank Rubio, as seen there on your screen, they will crew the mission, and it's slated for 2027.
It's a great crew, and it's also the penultimate mission, the final test before Artemis 4 attempts to put astronaut boots back on the moon for the first time since 1972. We'll be launching a Starship with a docking port on the nose so we can practice rendezvous and docking with the crew. And one key test objective comes after docking, where we will be able to test out maneuverability of the vehicles together while in space. This has the new importance as the revamped plan for lunar landings used Starship to do the burn, sending astronauts to the moon from Earth orbit.
And one other cool ad, NASA is putting 2 SpaceX mini lasers on Orion to connect it to our Starlink constellation with the goal of enabling 4K imagery and video from the spacecraft while in space. So that's going to be pretty awesome to see.
Awesome views for sure.
Yeah, there's lots of excitement planned for next year as we all work together to send humans back to the moon. And speaking of sending humans to space, former SpaceXer and current NASA astronaut Anil Menon is actually up on the space station right now as part of Expedition 74. And he captured these sweet photos of Starbase during an ISS flyover. Hi, Anil. We're all waving back at you, buddy. It's awesome to see the whole picture here as there's lots of facility and infrastructure development going on. But Starbase isn't alone on that front.
Yeah, it changes every day.
Yeah.
But talking about other locations, work is well underway in Florida to get pads 39A and Slick 37A ready for future Starship launches potentially later this year. Starship launches from Cape Canaveral are key to hit the necessary launch cadence to get back to the moon, build a moon base, head to Mars, all the exciting stuff ahead in the future.
Yeah, exactly. And that future gets closer and closer with tests like today's flight. And with that, we are just under 6 minutes until launch. So that brings us to terminal count. Excitement is definitely getting traction down here as the crowd is gathering just behind us on the lawn outside, and happy to say, still not a cloud in the sky. Dan, how are things up at Mission Control?
Things are still looking really good, Kate. We are still not tracking any holds on the board, no issues with the vehicle or with the pad. Our range continues to be green, both in the Gulf and out in the Indian Ocean for flight today. We'll continue monitoring that all the way down into the final minutes. We are going to be closing out our propellant loading on the booster and the ship within the next 3 minutes. We're going to have about 11.5 million pounds of liquid oxygen and liquid methane on both of those stages once we're all done. Then it'll be time for the pad to essentially ready itself, where we clear out all of the prop that's been flowing through feed lines up into the launch mount, up into the tower. Those go back into the propellant farm, get it ready, and we'll do those final thrust vector control, those steering checks as we get a little bit closer. if we need to hold that hold time, it's new for this launch, and we saw it briefly on our attempt last week. That hold is set at T-minus 60 seconds now. That's where we can pause, we can wait if we need to just kind of hang out for any pressurizations, anything like that to clear. We've got a couple of minutes to hang there. We will only hold if there's an issue, and we're not tracking any holds on the board right now.
That's right. Now, once T-minus 60 seconds passes, a number of events will occur in rapid succession. Both the ship and booster will configure their comm systems for flight, and they will rapidly run leak checks on gas and fluid tanks. Meanwhile, the booster will be going into internal power, and its engines will get their final priming for launch. Those ship engines will also begin their ascent bleed profile, and it will arm its automatic flight safety system. There's a lot of mechanical activations on the tower side as well, with one critical step being unlatching of the quick disconnect, feeding propellant into the ship.
And once T-minus 60 seconds has passed, we still have the ability to rapidly recycle the count under certain conditions back to that T-minus 60 seconds point and hold there to assess what happened and if teams can proceed once again to T0. There's an estimated 5 to 8 minutes of hold time, and that's largely driven by the propellant temperatures that we see on the vehicle while holding. The flame diverter on pad 2, you can see it there at the base of Starship. That activates at T-minus 17 seconds. Now, if we trigger a hold after T-minus 17 seconds, that will result in a scrub for the day, as we've already turned on the water. Now, for those that have just recently tuned in, once again, our primary test objectives for today's test flight includes a successful liftoff, stage separation. We also plan to deploy 20 Starlink V3 satellites. We have real satellites on board. We expect to have about 20 minutes of available time to speed run some tests and really allow the Starlink engineers to put them to the test in that time.
That's right, and we also have the soft splashdowns planned for both the booster and the ship. Going to be super exciting to see if we can return those safely back, so that way we can get ready for tower catches again.
And just a quick check, we got our final green light from the range, not tracking any issues on ascent or out in the Indian Ocean for entry, so it was kind of the final go for flight that we wait for in these final minutes. Prop load now closing out on both vehicles. We have no holds on the board. Again, we've got that gate at T-minus 1 minute. We're only going to hold if there's a reason, and currently there are no reasons.
Coming up here in a few seconds, we should have, actually right there we can see on screen, that's the base of the Super Heavy booster. Those are the 33 Raptor engines, and we expect to see and there they go, the TVC checkouts, also known as engine wiggles. We're activating those thrust vector control actuators to ensure that those center engines and the inner radius as well have the ability to steer the rocket.
Yep, super cool to see how fast those move. I mean, in flight, it's amazing to see how it steers the vehicle. And we're coming up on that T-minus 1 minute now on our countdown, so let's listen in to see if we pass that gate.
And real quick, do notice that our stream is a touch ahead of the X feed on the right, like 7 seconds. That's because of how long it takes the X feed to get to us. Also, if you are in person, start watching the rocket now.
Still no holds on the board. 50 seconds to go. Starship.
There's quite a big delay between me and you if you're there in person. So watch the rocket now. It might be taking off. So here we go. I'll shut up and listen. Here we go. Let's go, Starship. Flight 13. Looks like we're in a hold now.
Flight tractors go for launch.
Oh. There we go. Okay, deluge, water deluge coming on. And got ignition. And lift off. looks fantastic so far. Flight 13, that's booster 20. You can see it spinning with all 33 engines lit up, looking fantastic. This is what we like to see, my friends. This is, wow. There we go. You can hear the sound, the rumbles, the percussive, the sound breaking apart from all 33 Raptor engines, just absolutely doing awful things to that air, to all those poor air molecules. But we can pull up here soon. We'll have the SpaceX feed side by side. This is looking quite good here. Great, good job. Yeah, everything's looking fantastic on ascent. I'm going to listen back in because we're coming up on a bunch of call-outs here and a bunch of things happening. So let's listen back into the SpaceX feed.
While it is still attached, to do that separation. As a reminder, we try to do a directional flip. So when you watch on your screen, we're hopefully going to be sending that booster towards the bottom of the frame. For the booster itself, it's like doing a flip up. It'll go towards the bottom of your frame. We do that by lighting the engines in a slightly staggered sequence.
Oh, that's cool.
Standing by for hot staging.
There we go. Hot staging you can see on our cameras. Looks good from what I can tell.
All but 5 engines down.
Cutoff. Tap.
6 ignite.
Backburn startup.
And the booster now doing its boost back burn. It looks like we lit all 33 initially. Now we're down to 13. We're seeing 6 out of 6 Raptors lit on the ship.
I think things are looking good.
Backburn shut down.
And boost back burn shut down. So it looks like we were able to get through the boost back burn this time around. That was one of the key objectives we didn't have on the last flight.
Nominal.
And we've got 6 engines lit on the ship.
That is fantastic.
All right, so that's the first of 2 burns that the booster is going to be doing to kind of send it back towards us. It's going to be landing a couple of miles offshore from Starbase, hopefully. We're going to try and get it all the way down to do a landing burn, where we're going to use those 13 center engines. They're going to ignite. That's what's going to really bleed off all that velocity that it's built up. And it'll eventually, hopefully, transition to 5 engines to kind of fine-tune its path in, and then all the way down to 3 for the remaining bit.
Yeah, this is looking
we've got
way
a couple
better.
Of minutes to go until we get there. So booster's going to coast for a little bit. Ship still seeing 6 out of 6 Raptor engines lit. 4 minutes into the flight. Ship's got about 4 minutes left. Getting some killer views. Kate, Nate, how was the view from from down there?
It was incredible. I mean, it just shot off the pad, and seeing all the crowd now running back inside to take views on the screen here, it was amazing.
Yeah, one of these days I'm gonna learn to not stare at the engines, because now I have a bright blob in my vision.
Right.
Now, speaking of vision, we could see both stages there on your screen. Starship's second stage is still firing its engines. You can follow along with that with the GUI down on the bottom right-hand side of your screen.
I did want to point out they have the views swapped on the
following
SpaceX
the
view. Well, now they kind of don't. Now they have 2
flight path as
ships,
well.
but for a little bit they had the booster on the right. We have the booster on the left, and the booster telemetry is the left corner of the right window.
Right.
But you can see the booster is now falling,
The booster right
and we'll be coming up on a landing
now.
burn here, in the next couple minutes.
Where it just lifted off 5 minutes
Starship
ago.
on nominal trajectory.
We are there.
Incredible. We are there. That is us.
I kind of want to run back outside and wave.
Right. Now, again, this booster is not planning to come back to the tower or the launch site for this particular launch. We are going to be planning to do an ocean splashdown just off the coast of Starbase, so hoping to still get some amazing views of that.
Pretty awesome to see the Raptor engines there on the left-hand side of your screen. We can actually see the plume there of those center Raptors. Those are the sea level ones, as well as the vacuum Raptors are the three on the larger ones on the outer radius.
Look at Ryan's tracking shot there.
Now, just like on tower
Absolutely
catches, we are
amazing.
going to be doing a 13-engine landing burn to slow the booster down. Hopefully, we can get a live camera of the booster right now as we're going into that phase. Awesome shot. You can see it there. So right now, the booster is using their 3 hypersonic grid fins to guide itself through the atmosphere toward its landing site. You can see we're only 5 kilometers above the sea right here.
Hammered startup.
Kind of see ignition
Those are
there.
the call out for a
Got
landing
really
burn
cloudy
startup for the booster.
there. Not all engines lit. That looks like a wonky amount of engines.
About to go wild here.
Animation.
And another awesome landing for Super Heavy. Congratulations to all the teams here at Starbase and at our SpaceX team. An amazing, amazing view.
That didn't quite look right.
Everything continues to go well with ship, as you can see there on your screen.
Shoot.
Yeah, we've got about
think-
a minute left.
I don't think the
with
13
ship
engines quite
on.
lit
Just
right,
looking at the
and it did
booster
not seem to have the
didn't
soft
look like
splashdown.
we
Yeah.
lit all 13 engines that we were planning for that initial landing burn. We were targeting a softer splashdown, and as you saw, it came in with quite a bit of velocity still. So landing velocity did look a little bit high, but really cool to make it all the way back this time to that landing burn. We'll dig in, figure out how to turn on all those engines, and then get to a full landing soon. But all eyes on ship. We are just a little ways away from getting those
Start up
engines
terminal
turned
guidance.
off. We expect it to burn about 8 minutes and change. And so hopefully just about 15 minutes to go. Sounds like we just got the
Sonic booms.
Yeah, we
here
sure
at
did.
Starbase
That was awesome.
from the booster splashdown. And engine shutdown.
There we go. We're gonna have a lot to talk about here. Once
All right,
they
Starship
go off
6
here.
Raptor engines have successfully shut down.
Nominal orbit insertion.
And there's our call out for nominal orbit insertion. So we got a ship in space. We've got a booster in the Gulf where we were planning to send it. It's a hell of a start to the day, Kate.
Yeah, it sure is. All of our colleagues here are filing in through the doors. A lot of people wanted to stay outside and hear the boom. And so it's pretty great to see a ship in space, and everybody's super excited down here.
That's right. And as guaranteed, it has been an awesome day so far. All this action in just 9 minutes now. And objectives are done for the booster. Just want to quickly flag that that booster did land in a clear zone. We clear those before launch, well ahead, so that we ensure everyone is safe before the launch and after. So we're getting ready now for our in-space objectives.
Yeah, we've got a few minutes until the next milestone, so sit tight and enjoy the space views and, of course, the space jams. We'll be back here at T+14 minutes to deploy our payload, which is 20 of our newest Starlink version 3 satellites. So we'll see you soon.
Okay, so we will let's pull up those milestones here when we get a second. But a few things. First off, I saw some black little dots floating away. I hope those aren't heat shield tiles, because that would be not ideal. And we seem to have potentially lost the X feed here. Hold on, just give us a second here. But as noted, obviously, the landing burn did not go as intended. They're supposed to light all 13 Raptor engines on landing. And what ended up looking like it's happening, we'll have to probably mute the music too as well, so we don't get a copyright strike. By the way, it's not, SpaceX doesn't offer up the copyright. I get copyright strikes on my own stuff just because of all the automated systems on like YouTube and stuff. So that's why we try to avoid it, because it can cause a bunch of headaches and it can literally shut down streams if you don't stay on top of it. So the booster did not seem to light all 13 engines successfully, which led it to not slow down fast enough, and it led it to clearly having too much velocity when it hit the water. It's supposed to basically hover above the water and then shut off. That did not happen, and this is exactly why they didn't go for a catch today. People are asking, well, they've caught ones before. These are all new engines. There's all new plumbing. The entire V3 booster is basically a brand new design, right? The plumbing is so different. Going down through the booster and the landing tank and the giant massive transfer tube, all super different compared to anything that we saw with version 2 and version 1. Obviously, the Raptor 3s are radically new engines. When I say radical, I mean like the definition of radical, where they're just absolutely like nothing else ever built. And they're still got teething pains, and it might be a little while before we start seeing this actually be reliable. We kind of got spoiled by, Raptor 2 ended up getting pretty darn good by the end of it. And we're still in the relatively early days of Raptor 3. Not what I think SpaceX wanted to see out of the booster today. Does that have massive implications? No, because there's like 10 more in line to fly in the near future and literally hundreds of engines waiting for their turn. However, it does mean that we're delayed another catch of the booster by at least one more mission. This means we will not see a catch for Flight 14. They will need to validate that before. Okay, so we're into that. Where's the last one? The last timeline thing. Here we go. Payload deployment at 1640. So that's coming up really quickly already. So we're going to start seeing the payload bay door open. It'd be nice if it happened to be during the day so we could get better views of it. But I have a feeling the vehicle is going to be flying into space nighttime here awfully quick, since it's flying east away from the sun. You can almost get a sense that the sun's about already on the horizon in this shot. So we likely will be seeing that deployment in night, sadly. And night happens every 45 minutes when you're in low Earth orbit. So a little bit of a bummer, but hopefully still get good views of that deployment sequence, which will be really fun. So moral of the story is we will see at least another flight 14, before we see a catch. And like I said, I'm still half expecting 2 launch attempts, 2 of those soft splashdowns, one nominal, completely normal, and then one off nominal, intentionally off nominal, to be able to validate, if there was a situation almost like this. That would have been really bad if that came back down to the launch pad with that much velocity. That would have been a very bad day at the pad. So that's why they validate these. That's why they do that. Again, we got spoiled. They've caught 3 boosters in the past, all of them being version 2 boosts. Well, no, one was version 1, wasn't it? The first one was version 1. Flight 5 was version 1. Yeah. Anyway, we saw version 1 and version 2 catches of the booster. We got kind of spoiled by that. That became pretty quickly like, oh, they know how to do that. We will see that. But again, when everything is brand new, you do expect some teething pain. So that's where we're at, and that's okay. Again, I can't wait for the stock to probably go down like 20% or something, just because one milestone. But that's going to be what happens when you're publicly traded, I guess. But that shouldn't matter in the long-term viability of this company that's that's got a lot going on. And yeah. All right, well, let's keep going here. We're a ways behind. I had a good question here from somebody that I wanted to get back on. Let's see here. Where was that? I was kind of in the middle of answering it, and then we went to air. Let's see here. It was about the one from Macho Taco. I'm just going to fly through this. My favorite launch moment memory was honestly Artemis 2 is really cool. I would say the first time I saw a booster catch was really cool. Falcon Heavy was like all time. The first Falcon Heavy mission in 2018 was incredible. And then looking forward, I mean, it's going to be hard to beat watching Artemis 4 launch humans to the moon. Like, that will be one of the craziest things ever. So let's keep answering some questions here. This is from non-zero probability. If they start launching daily, do you think Boca Chica would even allow that? Would they ever move offshore? So they, a long time ago, like 5 years ago now, they were looking at doing, oil rigs for launch platforms. SpaceX is talking, so we're going to listen in.
Our payload. We don't have those cameras on board these Starship version 3s. That was a Dodger Dog exclusive, but we will be able to see them deploy from the ship.
I thought they had a bunch of cameras on the version 3s. I swear they wrote that up in their thing.
As Kate said, we should see the
Talking about not having cameras?
really soon if we haven't quite gotten it open already. We've got 20 of these Starlink V3 satellites. Looks like the PEZ door is open. And so, yeah, this is the first time we've got Starlink V3 satellites getting ready to go into space. And I mean, these things are really just kind of crazy upgrades that they're going to bring to the network, where you start talking about just symmetric gigabit speeds through the Starlink network pretty much anywhere on the planet that this is going to unlock. So really exciting. These satellites are only going to be in space for about 20 minutes.
So hold on, I'm just reading. So maybe I missed a little bit of what Kate was saying, but I swear she said something about not having the cameras on board. And according to SpaceX's own website, 6 of the satellites have been modified with a suite of cameras to scan Starship's heat shield and transmit imagery. So I don't know, maybe something changed, but I'll just listen in and shut up.
Arrays, antennas, whatever we can on these vehicles. We are intentionally being a little scrappy with it. They might be playing some bumper cars once they're out of the door, but we are looking to get these deployed over the next couple of minutes. In the meantime, they're getting ready to also do the Raptor in space relight. Listening to a little bit of conversation on that, but we are currently tracking to do it. I'll give you some updates if we hear otherwise.
And there you go. You can see our first Starlink V3 getting deployed out of Starship. Huge milestone for the team out here.
Yeah, the crowd is definitely hyped about this. We could see these Starlink V3s continuing to pop out with deployment assisted by the PEZ dispenser. Now, this version of Starship is built to deploy up to 60 of these more advanced Starlink version 3 satellites. Each V3 is designed to offer 1 terabit per second of downlink capacity. Now, let's put that into Falcon 9 terms real quick. A Starship launch with V3 satellites will launch 20 times the capacity into the constellation as a single launch of V2 satellites on Falcon 9. Just incredible.
And anybody that follows Starship, you know that the views that we're being treated to right now, the views we get during those re-entries, that's made possible by Starlink. It's given us just this unprecedented look into Starship as it's flying through space, hurtling through the atmosphere. It's powering the dozens of cameras we have on board. It's giving us real-time data on every system that's telemetered on board that vehicle in real time. We use the exact same constellation to power all of our cameras that we have out in the field here in the Indian Ocean. So really powerful technology for just connecting you no matter where the heck you are on the planet, off the planet. So thank you, Starlink, for letting me watch this stuff as we fly through space. It's pretty awesome. We get about 240 megabits per second of data rate off Starship, which everybody in the spaceflight community knows that's pretty insane when you're usually dealing with single digits on some of the older systems. So gives you a lot of insight, gives you a lot of ability to just rapidly iterate, know what the heck happened when things go wrong. But looks like we're seeing some more satellites get out the door. We do have cameras on some of them. The last couple that are going to go out are going to try and do the heat shield imaging that we attempted last flight. We don't have that camera view that we got on Flight 12 where you kind of see the satellite leaving Starship. Those aren't on the V3 satellites, but we are going to, on the last couple that go out, have some pretty narrow field view cameras that are going to be looking back at Starship, turn on some flashlights. And this is a test of a capability that we're really going to want when we start doing orbital flights, to just add that extra layer of safety, that extra layer of reliability, where we're going to be able to image Starship's heat shield after it's gone through ascent, after it's been in space, before it re-enters. So we're going to try to test that again today. The heat shield imaging, we didn't get a whole lot last time. Ooh, looks like we got some thunderstorms on planet Earth below us, but
cool.
A couple more satellites to go, it looks like.
Yeah, it's pretty awesome to see our V3s in space. I want to give a shout out to our Starlink colleagues. And we expect payload deploy to run until about 27.5 minutes, so about another 7 minutes here. The Starlink team will be attempting to speed run these tests, or excuse me, speed run test these version 3 satellites, where they will attempt to do a few tests such as extend the new solar arrays and antennas. They're also going to try and connect these V3 satellites with ground stations and turn on the satellite's communication systems. Now, they're only going to have about 20 minutes or so to do all of this, as these satellites only have that long before they demise in the atmosphere or break up due to that friction when they re-enter the atmosphere. So what we learn from today's deployment will help progress and move the program forward, which is super exciting. You could basically say that the payload's payload is data.
That's right.
We're getting very Inception here. Now, in addition to those tests for Starlink, for the Starlink team, as Dan mentioned, 6 of the satellites have been modified with engineering cameras to help scan Starship's heat shield. That will help inform our analysis of Starship's readiness for future catch returns back here at our launch site. So for those that might be unfamiliar, we are currently capable of catching our super heavy booster, and we've done that a couple of times. We have not yet attempted to catch our second stage or ship, and so that is going to be a very exciting milestone when that day comes.
For sure, and we're building up to it with today's tests. We are still planning to do our water splashdown in the Indian Ocean, so stay tuned for that. That's only about 40 minutes away. But still, in space, we keep on deploying our Starlink satellites. Again, these are our V3 version of our Starlink satellites, a whole host of added capabilities to our version 2 that's currently in orbit.
You got to be getting close to the ones with the flashlights on them, right? Or I mean, with the cameras on them.
Starbase, Texas.
These are all of the team members that have helped build the vehicle, that have built the Pez dispenser, and got it ready to fly today. Amazing work.
Now, for those of you that have just recently tuned in, there is a spaceship in your screen, we promise. Right now, the ship is in orbital darkness, so we don't have any available sunlight from the sun to help illuminate the scene. But what you can see moving out from that smally lit space, those are the V3 satellites as they are being deployed. And essentially, the ship is illuminated from the inside, and so we're able to see the light come out through the payload door.
Right. Just a really small sliver of light at the top. That's our Pez dispenser. That's how we're both loading our satellites into the rocket and deploying it. It's pretty novel. We've got about 3.5 minutes still left of our payload deploy sequence.
Yep, looks like we've got 16 satellites deployed, so 4 more to go. These last couple will have those cameras, so if you see any sudden bright lights, that'll be flashlights turning on those satellites to try and get some imagery of Starship's heat shield. 17 out the door. 3 more.
So last time, they really only got images of heat shields that are on the leeward side, where it's on the basically the backward, not the main heat shield. I always wondered if they'd like consider flipping Starship around so you could actually see the proper heat shield.
We are still going for
but
our
Who knows?
Raptor relight demonstration a little bit later in the flight today, so we will be looking to relight one of those Raptor engines on ship. And that'll be our next major milestone after we get through these final 2 satellites.
A lot of good questions. I'm even seeing things, like why do they do this? Well, with the V3s. And again, to be able to test them, even if it's for 20 minutes, to be able to see, make sure all the kinks are worked out as far as deployment and as far as the V3s actually becoming operational, opening up their solar panels and all that stuff. Valuable data.
Lost count, we have deployed almost all of our 20 Starlink satellites. I believe our last count was at 18, so we should be seeing 2 more. And we're very excited to see our version 3 satellites in space. And these are fully, these are real satellites. Right. They're not just demonstration sats like we had last time. These are going to basically have a 20-minute lifespan where our Starlink engineering team will attempt to perform a number of tests and really speed run those tests during that time.
Right. And in terms of satellite lifespans, 20 minutes is it's the shortest you could possibly get, but hopefully in that 20-minute time frame, we can really try and ink out as many tests as we can.
It looks like we might have some. This might actually be light from one of the Starlink satellites. As we mentioned before, a few of them, 6 of them actually are equipped with flashlights to look back at Starship, as we want to image the heat shield and understand the heat shield performance through the ascent phase, as this information is very important for us to know and understand as we prepare for operations that will enable ship to come back to Starbase for landing. For catch, I should say.
Right. We are about 40 seconds away from that planned payload deployment sequence being complete.
Yep, looks like we've just got those last 2 to go. These ones might be coming out. Oops, they're starting to see motion. 19 out the door, 1 more.
It looks like we got a crowd at our Hawthorne, California location. Some colleagues gathering outside of mission control there as well.
That marks, if I'm not mistaken, our 20th. So our payload deploy sequence is now complete. Starship will now close its payload bay door and continue to coast around Earth to the Indian Ocean. Still a lot of major events to come today, including our Raptor relight burn at T plus 38 minutes, 58 seconds, followed by atmospheric re-entry, where the heat shield will be put to test, and eventually our splashdown. So with that, we're gonna go ahead and go on to another quick coast.
Yeah, so sit tight, enjoy the views, and of course some more space jams, and we will come back here at T plus 37 minutes for our Raptor engine relight and of course Starship re-entry.
Okay, so we have about 9 minutes, is that what it was? Or 8 minutes left until they do that. So let's answer some more of your questions. And again, I just wanted to say, just on a personal note, thank you guys so much for those of you watching with me. And yeah, this is really fun for me. I love seeing this, especially with the Starlinks lighting up the Starship upper stage while it's in basically orbital night is fantastic. Sadly, we might have to mute the music even more than this while just so it's not ducked out. Just by the way, it looks like you can actually see the Starlinks up there in the upper left or something of them. I wonder if they're actually going to be doing maneuvering. I always thought it'd be sick if they maneuvered to the backside to be able to actually see the proper, heat shield side, like I said. Or are they rotating? They might be rolling. No, because those are staying. Oh yeah, let me think about this. Are those staying relative? It's hard to tell. Look at the shadow. Look, watch the shadow. Okay, well now the flap's moving, so that's not helping me figure out orientation. But if the shadow moves on the vehicle, roll-wise, oh, I'm lost. I don't know. I was trying to figure out if they're putting a roll into the vehicle. This doesn't count because this is them moving the flaps and the cameras are attached to the flaps. So therefore, it looks like, movement of the ship, but really it's It's the relative motion of the flap on the ship, not the ship itself rotating. But I'm trying to see if they're. I don't see any thruster firing either, but I was maybe expecting them to try to do like a barbecue roll where they let the heat shield side face the Starlinks, so the Starlinks can then get images of the heat shield before they re-enter, which would be really cool to see. So, but again, yeah, thank you guys so much for watching with me. It really does mean a lot. If you want to support the work we do here, again, until midnight tonight, we have 20% off of our 1969 collection and a lot of other, and our translunar collection as well is already 20% off on our web store, including the shirt that I'm wearing, which is our Orange to the Core pocket tee that I love so much. You can find those at everydayastronaut.com/shop. And that's going to be, something that ends at midnight, but 20% off is already included. You don't need any kind of code or anything. By the way, yeah, I'll pull that up here real quick. In the corner, I was going to pull this up here in the side. You guys can see that. That's the shop 20% off. I did notice that the Starlink satellites did appear to move relative motion to, like, I think they're off to this side of the ship now, to the port side of the ship if you're sitting in it, because now that's getting dark. They are imaging the actual heat shield side. I said that right. That is going to be amazing. So notice that the top of the ship, from what we see, that's the leeward side. That is getting darker. The heat shield side is getting lighter now. It's getting illuminated. They are rolling it, and they are getting images of the actual underside of the heat shield before they re-enter. Now that's cool. That's fantastic. Okay, that is amazing. So they are doing what I was hoping they would do. Great work. Okay, anyway, if you want 20% off of, and you want to support the show and just whatever, you want something cool on your body, everydayastronaut.com/shop. Some of our coolest things, like our A7L hoodies, our Apollo hoodie, our lure tour shirt, our button ups and things like that, our jogger set, and even some of our translunar coast stuff is 20% off in honor of the anniversary of Apollo 11. So everydayastronaut.com/shop, get 20% off, support the show, get something cool for yourself. Yeah, what do you guys think? I mean, this is actually, I'm again a little disappointed in the booster landing, but they'll get that figured out. They've done that before. And this is exciting, though. This, to me, the fact that they're able to test this stuff, that the satellites are working well, that we're getting illumination and cool light changes because it's doing a roll in space. And now you can see that side of the ship is illuminated, where as the starboard side of the ship is now illuminated. Really cool. Really cool to see that. I like this kind of stuff. I wanted to answer this question real quick. I'm still trying to get through our massive queue, and I don't have a ton of time. Hotel Snob says, do you think all 4 rockets scheduled for August 30th at Cape Canaveral will launch in one day? No. Lots of times when you see, you can see all the Starlinks out there, like a chain of them almost. That is cool. That's like UFO stuff. Count me in. That is so cool to see. Oh, I love this. I love when they do cool, weird things that I've never seen before and that have never been done before. And this is one of them. There's a cool, weird thing that I've never seen before. Amazing. When you see, like, when we're more than a few weeks away from any rocket launch and on a rocket app or something, like next space flight, a lot of times those are just placeholders. They're aiming for August, and so they might put them all at the end. The ones that are just kind of placeholders of they're expecting to launch in August might just move to the end. So don't take any launch date you see that's more than like 2 weeks old as solid truth. Think of it more as like a general maybe. As that gets closer, those probabilities go up. So if you're a week out, anything on the calendar does tend to firm up a lot. And if you're, within days, then it firms up even more. So a lot of placeholders in that, and a lot of external variables can change that as well. So let's keep moving on here. During the abort, there's a puff that came up between the booster and ship. Is that normal? And we just don't notice those during a normal launch. That might have been, did the QD disconnect on the abort? I don't actually remember. I didn't look into it that closely, to be honest. So I don't think that is, maybe that is normal. Maybe that would be a normal thing during a normal launch, but we just happen to see it because it didn't go anywhere. Yeah. We actually do have the aborted shot. Can we pull that up, Spencer? I think we actually have the aborted shot. I can try to analyze for a second if there's something, because a lot is happening during startup, even on the other stage. This was the abort from last week. We've got stuff happening. That looks like an abort. So sadly, I have like 720p on this right now, so I don't actually have a... Okay, this one might show a little bit better. Yeah, it's a 15. And when we get a little close, you can actually go full screen on that for me. And then I can maybe get a little better sense of it. That does appear to be like a QD event, the quick disconnect event. I'd have to look at other shots to know if that for sure is normal. But that might be normal. I don't know. That didn't look, energetic or anything. Sorry. And again, if you're just now joining us, that was last week's abort. Good question. Probably something you could learn from that, actually, if you knew exactly what, where, why, and how. I love, by the way, seeing all those Starlinks out there. And now it's starting to become, they're almost flying into daylight now, too. And they're going to start experiencing some, and the Raptor relay, by the way, will help them get away from those Starlinks so they don't accidentally, have Starlinks run into it during reentry, which could potentially be a problem. Astro Joe, 43 months of membership. Thank you so much. From Thomas B, shout out to my son Harrison watching at home. Thanks for your coverage. Well, thank you so much to you and your son. Greatly appreciate it. Oh, SpaceX is back. Let's listen in.
Newest version of Starship, which you see there on your screen, successfully deployed 20 Starlink version 3 satellites. And I've got great news to share. Not only were we able to make contact with all 20, but we also made comms over lasers with all of them as well. So that is awesome. Hell yeah, shout out to our Starlink team. We're so thrilled.
Huge milestone. And that's only 3 minutes or 5 minutes after deploying them? I mean, that's crazy.
Amazing. And right now, we are expecting a relight of a single Raptor engine, and that's going to be coming up in just over a minute and a half from now.
That's right. We are going to be lighting one of our sea-level Raptor engines, and this is essentially just a demonstration that you can relight an engine after it's already done its ascent burn. And this is going to be really important when we do maneuvers for orbital missions, whether we're relighting to go into orbit, or if you're already in orbit and you're getting ready to do a deorbit burn. We did hear our Raptor team is go for the engine relight, so not going to be skipping it on this one. So we should see that coming up in just about 45 seconds from now. Again, this is not a deorbit burn for this ship. We are on a suborbital trajectory, so this Starship is coming back over the Indian Ocean no matter what. But this is going to be a pretty critical test for what we'll eventually need to do when we do orbital missions. When you got to relight those engines, do a burn to get yourself out of orbit. One thing that is unique on this one is we're going to be lighting it for a little bit longer of a time. We're expecting this burn to be up to about 14 seconds. We've only done about 3 seconds previously. And so that should be coming up within the next couple of seconds. Let's stand by.
I'm excited to see those Starlinks move away relative.
You see relight there on your screen.
Wow.
And confirmation over the net. Relight shutdown. The burn has ended. Congrats to the team on this milestone. I mean, it's crazy to see how we can maneuver in space, and just another icing on the cake for today's mission. So we're going to be taking another quick break. We'll be back in a couple of minutes before re-entry, which is targeted for about T plus 47 minutes. So we'll see you soon.
Okay, is anyone else confused? Like, just I'm confused about the plume, the plume interaction, and like what exactly we were seeing from that external view. That was really disorienting to me. What's that? And by the way, you can see Earth on the bottom there, kind of moving by on your screen now. But man, that for some reason was like, that hurt my head. That was like really hard for me to wrap my head around. I don't know why. I'm gonna rewind for myself and take a look here. And see if I can like wrap my head around, because it looks relative, like things are moving, like it's already in the belly flop, but that's not really what's happening. I mean, yes, in a way that is what's happening, but I don't know. That just looked very different than what I was expecting from the external view of a Raptor engine lighting. It was really cool, really mesmerizing. But that was crazy. Wow. That looks so weird. I don't quite get what the streaks are underneath the rocket that we were seeing. And yeah, that is hard for my head to wrap around. I know I can't be alone on that. I know I can't be alone. And they are, what you're seeing right there, like those clouds and things, it is venting constantly. There's a lot of, boil off. There's a lot of venting going on, a lot of things to hold in attitude. And we are only at 126 kilometers in altitude. So believe it or not, even at that altitude, there's still a decent amount of atmospheric drag. Like there's air molecules flying by for sure. And so we do see some relative motion there, but I don't know why the plume interaction was just like really hard for me to fathom. Really cool. Again, I love seeing something that I've not seen before like that. Matthew Parker says, boo, sorry for the boo. Derek Lies, thank you so much for your super chat. And also Randy Hildebrand, thank you so much for your support. Let's see here. We have a lot of super chats. I'm going to try and fly through a few of these super chats until SpaceX comes back up. Thank you, Klondike Saloon. Alex Lockhart, thank you. Can you say hi to my son, Killian? Hello, Killian. Thank you guys for watching. Hopefully you see a really great reentry and a smooth splashdown here of a Starship here in the next 20 minutes or so. That should be really exciting. JK354 Kit Kat had around 400,000 bars stolen. That means that Starship could be launching roughly 10 million Kit Kat bars. That is great news. They should be doing that. We need that quick, 45-minute to anywhere Kit Kat delivery for sure. Yeah. Sorry, I'm trying to pay attention also to our Discord channel, see what everyone's talking about. Okay, from Seacano Chaos saying hello from Space Coast, Titusville. Cannot wait for Starship launches from the Cape. Let's get some tacos. Amen. Thank you so much for that support. When Starship starts flying from the Cape, it's going to be really exciting. That'll be like, that'll be the one to see from the Cape. From Zero Kelvin, thank you so much for great space news delivery. I can't wait for this launch. Hope it goes through. Love your channel, the way you present news. Love What About It and Marcus channels, but you are the best. Thank you for everything. Well, thank you for saying that. I appreciate that. I always have, the greatest respect for all the people out there, Marcus and Felix and all the NSF crew and lab crew and everyone that's doing all the more daily and weekly news things, because that's how I stay in touch with all this stuff while I pursue, kind of deeper dives on things. It's amazing what the community is able to keep up with and bring to everybody. So yeah, huge shout out to the whole community, including all of you that watch this. If all of you weren't tuning in and watching these rocket launches, I'd have nothing to talk about and no one to talk to. So huge appreciation on my end. It's really a dream come true. We are starting to see a little bit of that reentry dynamics already. A little bit of plasma starting to build up. It's crazy how dramatic it gets so quickly. So Float Globe coffee for the tomorrow morning on Float Globe. We're on Kickstarter. Let's go Flight 13. Love you guys from Float Globe. Thank you so much for your support. It's awesome to hear that you're also on Kickstarter. So good luck with that. Bud Moore, thank you so much. K Blick. So one Apple sessions again. Appy sessions again. So when Appy sessions again? I'm not sure what that means, but thank you for the ongoing membership. $50 from Jason Stansel. Hey, Tim. Hey, Jack Byer. Best wishes. Good luck from Astronaut Payload from Dripping Springs, Texas, from the Astros. Amazing. Thank you so much, Jason. Really great hearing from you, and thank you so much for your support. Really, really appreciate it. man, I'm quite a ways behind, I think, because I'm seeing some really generous supports that I did not get to. Penguin Man, my Civil Air Patrol cadets, next Thursday we will study rocketry history and notable figures and learn more. That's amazing. Appreciate it. But we have SpaceX coming back in, so I'm going to listen as we go through reentry.
The ship is currently re-entering the Earth's atmosphere. Now, we probably have some first-time viewers tuning in today, so let's talk about this phase.
Right, so re-entry, it's a critical phase of flight, and we need information on how the ship's systems perform. So re-entry, you can see that speed in the bottom left-hand corner of your screen. We have to scrub all of that speed down so that way we can safely land. It's a lot of energy to be able to scrub down, and it's all the energy that we just used to launch the rocket as well. So Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests, is to see how the ship performs in space and evaluate how it works. Starlink provides us with one more path to collect data to help us rapidly iterate Starship's design.
Yeah, exactly. And if the ship manages to again make it all the way through re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere, and it's doing so at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or about 5 miles per second. So at those speeds, the spacecraft is moving through the atmosphere so fast that it creates a plasma field around the vehicle.
That blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. Starship is designed to land on Mars, where there are no runways or other humans to help out, which is exactly why we're testing this landing procedure that we're doing today. And we're doing these propulsive landings instead of more traditional means like parachutes, because propulsive landing...
control of the vehicle.
You heard that call out, flaps do have control of the vehicle. You can actually see one view, your screen moving around. That's actually a camera affixed to the flap. So as I was saying, we're testing these, doing these landings instead of more traditional means, so that way propulsive landing, we can enable more rapid reusability.
Yeah. Now, we did just hear that call out. We should continue to hear some call outs as the ship makes its way back to Earth. Now, when we hear something called entry max heating, as well as entry max Q, that means that the ship has made it through the maximum heating and aerodynamic loads that it experiences as it returns. So, safe to say that if it makes it through those specific points, we're doing pretty well.
That's right. So we'll continue to hear multiple callouts as we go through this phase. One of those callouts will be that the ship is transonic. We'll also hear another one when it's subsonic. Transonic will be referring to the period of flight where velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most fly at roughly Mach 0.74, 0.85. Just for reference, that's between 480 miles per hour to 575 miles per hour, or 770 to 930 kilometers an hour. And subsonic, another call out that you'll hear later on in the stream, subsonic will refer to speeds that are much less than the speed of sound. So at this point in flight, the ship's velocity will be slowing down drastically. So with reentry well underway, we'll take another break and return just before the ship's landing burn, targeted for T+1 hour and 5 minutes.
All right, so I guess they're gonna give us another 10 minutes to talk. So apparently, by the way, Appy Sessions was in reference to when I was with some supporters in Ghent, Belgium. We went and found beers at a place, and I didn't know that was called Appy Sessions. I did not realize that was called Appy. I forgot. So of course I remember. However, I did not remember the name, which is very typical of me. Thank you so much to members and from Emery's and Dino for 2 years of membership. 50. I think these are Great Britain pounds. Yeah, BPs. So Ian Jeffries, thank you so much. Yeah, thank you. That's very, very generous. Robert Surjan, thank you for becoming a member. Better audio, thank you for noticing. This is from Gianco. Hello, when do you think Starlink will be used like cell phone usage? I mean, we're already a little bit there. If you have T-Mobile, sometimes you'll notice that you're actually on Starlink, but it's very limited usage. It's like just light amounts of bandwidth. However, the one key thing is that you have to have like direct vision to the sky for Starlink to really work. So it will always be a good tool like on a road trip or hiking in the mountains or in the middle of the, on a cruise ship on the top deck. However, you'll notice that I obviously just went on a cruise with my family, so I'm thinking of cruises. However, if you go below the deck, you'll have to rely on repeaters or traditional Wi-Fi that could be powered by Starlink. But to replace cell phone, because the penetration is so good with cell phone towers being really close, they can be high powered, they can get inside houses, get inside buildings. You don't have problems there with reception. However, Starlink being so much further away, so relatively weak signal, I don't know if we'll be getting Starlink to your cell phone in the middle of a building anytime too soon. But direct to cell is already happening, and it's just going to be ramping up, especially with V3. So expect that to be just continuing. Yeah. Do you want to know when the first crew launches? Absolutely do not know. The first crew that will probably step foot in any kind of Starlink or Starship will be the HLS crew for the Artemis programs to land on the moon. That will be the first time a crew boards a Starship. When will the first time they launch a crew with Starship? I have no idea. And I don't know if that's when or how they'll do that without, some kind of, any kind of abort system. So I have no idea, unfortunately. Moon THC, thank you so much for your generous donation. Again, thank you, Lex Friedman. Again, you are too generous on all these streams. Thank you so much. Really, really appreciate the support. And an even bigger one, I did not see this. Jack Ham 13. Absolutely massive $500 super chat. Thank you so much, Jack Ham 13. Holy crap. Oh, man. Everyone say thank you to Jack Ham 13. Yeah, that's super, super generous. Thank you. You've made it all worthwhile. We've had to have crew down at Starbase for the last week now, and that gets expensive. So I really appreciate the support. That makes this all doable. So huge thank you. Everyone say thank you. That is crazy. That is huge. Really, really appreciate it. Adam Barry, 3154, thank you so much for your support as well. And freaking Moon Kid just became a member. Is that actually freaking Moon Kid? Because that'd be awesome. Oh, man, that'd be so cool. Average Joe's BB, how will the landing flip feel to the astronaut? So I actually have an older video now. It's probably 4 years old about the belly flop maneuver specifically. And I go through all the math. I go through the G-forces. The reality is like the G-forces aren't actually that great. And the flip itself is relatively slow. Like it's a reasonable rate of rotation where it wouldn't be anything beyond like a roller coaster or anything. And it'd actually be relatively low Gs. And you could offset it completely by just having like rotating or swiveling seats that counteract the actual flip movement. But it's not the ship actually lands quite like pedestrian, we'll say. It lands with very low like G-forces compared to the booster. The booster's landing has some extreme G-forces. Like when it slams on the brakes, it's pulling like over 5 or 6 Gs. And when it's doing like 13 engine landing burn at the end, it's very high Gs as well. So that would be, you don't want to ride the booster. You do want to ride the ship for sure. Andrew Romash, why don't they try to start other engines to compensate for the failed ones? So they basically only have enough like headroom to be able to spin up a certain amount of engines, most likely. And the outer ring of engines don't gimbal. However, they obviously all can relight since they do relight them during the boost backburn. Maybe they'll start implementing that where like if they have an inner engine go out and it'll immediately kick on kind of, the closest neighbor. That could be really cool. Yeah, the flap, you can see the heat shield's glowing pretty hot there, but it's all looking pretty good so far from what I can tell. I love this view, and it's only going to get more intense here for the next Oh, I'd say about 5 minutes, 4 or 5 minutes. This is a really good question from Everyday Space Nerd. Why do the sea level raptors have mock diamonds in space? I thought that only happened in the atmosphere. I was actually noticing that too, and I was trying to figure that out. It might be, again, like the plume interactions between the other, like the sea level engines interacting on themselves, and then also the vacuum engines interacting on that, making it look almost identical to mock diamonds. But it looked a lot like mock diamonds. I need to study that a little bit more and see what actually was going on there. From late for my 8, keep it up, John C. Thank you so much, man. You guys were way too generous today. Thank you so much. Really, really, really appreciate all the support. Seriously, that's yeah. We have a big crew and a lot of moving parts and mouths to feed, and a lot of people making this possible. So thank you so much for that. Seriously, that's huge. Starship Artemis says, if they retire Falcon 9 in 2028, will they have Starship with a different payload opening? And I answered this because obviously not everything would fit through a PEZ dispenser. Has anyone seen what that will look like? Yeah, and I answered that in Discord, as you know. But for the rest of the audience here, there is kind of like an alligator mouth that's been seen by official renders from SpaceX for years. And that's what will have to happen if you're to deploy any non-traditional or non-Starlink PEZ payloads. There will be like a large alligator mouth that basically opens up. I have a video coming out soon with Starlab, where they're going to be launching on Starship, and they're relying on having something like that to be able to launch their massive vehicle. So let's see. Man, you guys, just Rick, I don't always get to see launches, but I can always count on you being here, doing your best to show us everything and answer everything. Well, thank you so much. Really appreciate that. From Wheelbarrow with $50. Again, thank you so much. Hello, Tim. Anything we should be looking for on this reentry in the ship? So I would say just really looking on the aft side or the leeward side of the flaps. So not the side that's experiencing the plasma, like on the left, but looking on the right from this angle. The part that's not getting hit by plasma, we want to see that not glowing red. So if that's not glowing red, that's a really good sign. A little bit of glowing red's fine because, there's a large range where stainless steel or any metal really can get warm and warm up, and before it really starts to fatigue, and then it becomes, malleable, and then it burns through. But a little bit of like discoloration's okay, but we really don't want to see it like glowing red hot and failing. That's the big thing that we're really looking for here. But everything's looking quite smooth, quite under control. They're down to 55 kilometers in altitude. So they're really in the thick of it right now, quite literally, and still screaming. Just look at that velocity, 15,700 kilometers an hour. That is absolutely incredible. That's like, we're at 10,000 miles an hour still. That is just screaming back in. Ruth, thank you so much for your super chat. Chris B, thank you so much as well. Mad Burgundy, this is one of the coolest things I've ever seen. I hope you were in person because it's definitely the best in person for sure. I like to be able to, stream with you guys here and bring you guys the best we can do, but there's nothing like seeing a rocket launch in person. So I hope that Mod Burgundy, you were there in person. Let's see here. Hawks 3918, the cool light showed during Raptor relay was probably the reflection of RCS thruster plumes that were counteracting the movement made by the relay. That's what I'm thinking. There's something coming out of from the front of the ship interacting, because there were also kind of those pulses. We had MG Steve, perhaps they had to fire a gas thruster due to offset thrust. So that's what was going on. It did look like it was going through a cloud. It might be something like that. However, I mean, the Raptors, those 3 center Raptor engines can gimbal. So I expect that to be able to keep it straight and not, it would just basically go a little bit offset like this, and it would be able to fly not relative attitude straight, but like in space straight, if that makes sense. At least like without changing its attitude, pointing in the same direction, it can point through the center of mass. So, but it did look like there's something else firing. I'd really love to be able to learn more about that. Crispy always thought, why can't Starship rotate like a hot dog in reentry? Would spread the heat around the whole ship, maybe too hard to control. Well, yeah, the big thing is, then you really do lose out on your control scheme, which is the flaps. And by the way, it looks like it pretty much already got through the spicy part, because it's already just back down. Now. We're down to 44 kilometers and slowing down to 10,000 kilometers an hour, so 6,000 miles an hour. And this now just looks pedestrian again compared to the re-entry part, the spicy re-entry. This looks like a little walk in the park. Spencer, let me know if they do go back to commentating. They probably will be. Okay, still music right now, so we'll bring it up as soon as they are talking. Yeah, the main thing is those flaps are its primary mode of control. By opening up the top and bottoms, they control pitch. By altering the left side to right side, they can control, well, it's a weird control scheme. We'll still call it roll. And then by counteracting opposite pairs, they can do yaw. Yeah, so you'd really lose out on your whole control scheme if you just did a barrel roll through reentry. And it also add a lot more mass. That heat shield is not free either. It's several, it's probably 10 tons worth of mass. If you doubled it to 20 tons, it's probably heavier than the flaps. But good question. I like those kind of questions. Morale, upstanding citizen, says they broke the firmament. They sure did, and now they're having to break back down through it on the way for the re-entry. Thank you for your support. Maxon Hedrick, did the engines illuminate the vent thruster plume? Could shadows from engine lights be the cause? Yeah, I think it's something. I'm just still trying to figure out the underneath the detached part interacting with things was what was really hard for me to fathom. Really fun to watch though. Cody Van Cleve, son and I just visited Starbase. Appreciate the content. Shout out to my son Oliver. Awesome. Well, congrats. Cool that you guys got to visit Starbase. It's really fun to see. Still highly encourage people if you are looking for a random road trip or flight or vacation destination. Pretty hard to beat that. By the way, that camera, you can tell it took a little bit of a beating there through some of the reentry. Really cool to see that. Yeah, it's really fun though to drive public roads and go up and see the world's largest rockets, and pretty amazing thing that you can do that. I don't know how long you'll be able to do that for, but it sure is fun. Timothy Buck, what do you think the next payload will be? Keep up the great work. They'll be flying Starlink for a long time. I think they'll be flying. It'll be a long time before we don't see Starlink being the only payload. So I wouldn't be surprised if we see, 10, 20, 30 launches of Starlinks before we, and then and in the meantime, also orbital refueling. I think we'll see in the first 10 launches, we'll start seeing refueling missions, and the fuel and the propellant will be the payload. But I think it'll be like 30, 40, or 50 launches before we see non-Starlink payloads be deployed. From Snappy, thank you so much for the super chat. Could ship alone do SSTO if you replaced all of the like sea level or the space, the vacuum Raptors, and did like 9 or 13 sea level Raptors? You could probably just barely SSTO Starship. However, it would get quite literally maybe like 100 kilograms worth of payload, so it'd be almost nothing. So let's listen in here and see what's what.
3. As you can see on your screen with crisp views from Starlink, the ship is currently re-entering the Earth's atmosphere over the Indian Ocean. And really for the last several minutes, we had some amazing Technicolor views. It really looked like it was made out of starlight. Now, we did hear on the nets just moments ago that we made it through max heating and max dynamic pressure, meaning that the vehicle temperature and speeds and pressure are all coming down, and we can see that in the bottom left-hand corner of your screen as that speed continues to decelerate. We're coming up to the ship landing burn. One of pretty much everybody's favorite part of Starship test flight days, and that's going to be coming up here in just about a minute or so.
Yeah, just about a minute away. We're going to try and light all 3 Raptor sea level engines for this burn. We'll light 3, do the flip. We'll eventually go down to 2 as we get close down to the water, down mode to a final 1 engine before we hopefully execute a nice soft splashdown. We'll see if we've got our buoys and drones in range with the recovery team. They're going to be standing by to try and get some additional views of Starship's heat shield, which from kind of our initial looks, it did pretty well on the flight uphill, but we'll continue to dig through all the visual data as we get it. We didn't do any real stress tests or anything on this flight. We did do, you heard our landing Larsh flight controller call out. We were doing the swoosh maneuver. This is kind of the final maneuver that we plan to have starships returning to Starbase do, that will essentially hook them out over the Gulf before coming in and over Tower 2. But about 10 seconds away, look for 3 Raptors, the 3 in the middle to light up, do a flip. Let's see if we can get this thing in the water.
Wow, look at it pass by that cloud. That's so cool. Here's 1, 2, 3 Raptors.
3 sea level flip. Seeing how the chamber pressure's on. Did our flip down to 2. Starship descending into the Indian Ocean. Down to 1. And
boom. Oh, it didn't blow up. Come on.
It's a soft splashdown in the water.
Here we go. Here we go.
That is a first. That is the softest splashdown we have ever had with the Starship there in the Indian Ocean.
It's bound to be an exciting day for our recovery team. I mean, that huge milestone to even get to soft splashdown, much less have the vehicle stay afloat.
Yeah,
I will
the teams are super hyped here. Got some crowd here at Starbase Texas. Everyone's super
Oh, now
excited.
that's valuable data for them right there. Being able to get that it landed with the heat shield like that, where you can now visualize the heat shield. This is like, oh, come on. That's what I'm talking about right there, is they're able to get some of that valuable data.
I want to check in with Tyler. Tyler, how is Hawthorne feeling about Lucky Flight 13?
Hey, Kate, we are so excited about another successful Starship test flight and those gorgeous Starlink views that we had. And we can also confirm that we managed to make contact with all 20 of those V3 sats. So it's a massive day for us. So congratulations to everyone at the team at Starbase, for Starlink, everyone here and around the company who've contributed to the Starship program as we make progress again towards a multi-planetary future. So thank you everyone for tuning in. That's a goodbye from Hawthorne, and back to you guys at Starbase.
Thanks so much, Tyler. Now, for anyone who perhaps missed the action, I suggest that you rewind the clock. Wow.
Oh!
The Starship heat shield tiles, you can really see how the atmospheric re-entry, how it disperses the heat around the edge of the vehicle. I don't think we've seen quite that close before.
Never. And honestly, however short-lived that ship standing, bobbing in the water is, that is insane data for our team. It's unbelievable that we were able to keep that ship afloat. Now, we promised maximum excitement, and Starship V3 delivered. Congratulations to all of our teammates at SpaceX and to everyone who supported the Starship program. And thank you to all of our future customers for your support.
Yeah, as you could tell, the crowd really enjoyed that Nemo cam for a moment. We'd also like to thank the fine people of Cameron County, as well as the Coast Guard, the Federal Aviation Administration, and the Government of Mexico.
The amazing views do not end, so be sure to follow SpaceX on X for updates and more of these exciting shots that we didn't get to feature on today's broadcast.
And to get an inside real-time look at the teams bringing this incredible rocket to life, check out the latest episode of our documentary series, Starship. And of course, thanks to all of you for tuning in. And we're gonna head back up to Dan for some additional thoughts.
Yeah, I'm losing my mind right now. We are still getting views from on board the ship with it in the water. Like, we had tried in the past to do these splashdowns as softly as possible. We experimented with rolls. This is the first time we've put an intact Starship in the water. This is a dream scenario for the team that's trying to get this heat shield data. Normally you're working with a slightly charred Starship in the water, and now we have one intact. So the recovery team is moving in with their drones, and we are still getting views from Starship. It is sending these via Starlink from the other side of the world while it is floating in the water after flying through space. Like, this is just completely surreal right now. This is just a mountain of data that we're going to get back. This is going to be so critical for refining the heat shield, everything else. And the really good news is all of these views that we're seeing, you're looking at a pretty intact looking heat shield, which, as a reminder, we were flying at a significantly higher dynamic pressure, so putting way more stress on this vehicle on the way uphill. And it's sitting there in the water, and I mean, look at it. So I'm a little bit over the moon on this. I know a lot of our team is just fascinated in the control room behind me. I mean, everybody is psyched. Everyone's gathered around their computers looking at these close-ups that we're getting of these heat shield tiles. 18,000 of them. I mean, you can probably count the ones that are missing right now on one hand. Like, this is just absolutely incredible. And the fact that, like, the cameras on board the ship are still sending back video is just a little bit surreal. So, wow. Lucky number 13. Hell of a flight for Starship. Get it all the way there in the water. Really great day for version 3. So, whew. All right.
Wow.
As Kate and Nate said, we're going to keep releasing more of this. Stay tuned. We've got some really cool stuff from some of the onboards that we caught, so keep following us on X at SpaceX. Whole bunch more cool imagery from launch from the flight that's going to be coming out soon. Yeah, let's just close on that. I mean, look at Starship in the Indian Ocean. That's fantastic. We'll see you all back here for the next flight test of Starship version 3. With that, we'll say goodbye.
Boy, oh boy, are we getting some interesting shots there at the end. Oh, it's painful that they're taking that away from us right now. That was, I've never seen anything like that. So we did hear them confirm they were trying to do some kind of softer splashdown and spinning and things like that. So that confirms 12 was probably trying to do something similar. I did notice, did you guys notice at the very end, they kind of let it try to like under propulsive power still, trying to like tip over. I think they were trying to do exactly that because it was even tilting in the way where the heat shield would be up. And they got their dream come true where they're able to sit there. Every single one of those frames of 4K video on that drone is worth, you know, $1,000 basically, because they now have really good visual representation of what's happening on that heat shield. And again, they were pushing it uphill, higher max Q, which means more stresses on those heat shields. They're also still playing around with really steep and higher dynamic re-entry as well, compared to like what a standard will eventually be. So if the heat shield's turning out pretty darn good, then that's going to make them feel really good about bringing one all the way back to land. So that is amazing. So the key is here, people, they are not going to want to recover this vehicle. At some point, they'll have to terminate it. They'll likely off camera, they'll probably light the flight termination system or trigger that to be able to happen. Or if they can't do that for some reason, they might literally have to shoot it. Yep. And take it out and then have it blow up because they don't want it sitting there floating where it's still pressurized. You know, if another boat or some, vehicle were to approach that, not only would it be dangerous to those on board, it'd also be potentially a big ITAR risk, a leak of information and intellectual property that they wouldn't want people just going up and being able to like take apart the ship and get pieces for themselves. So it's in their best intention to sink this thing in the middle of the Indian Ocean. By the way, stick around because we do have some replays coming up, and we've got a few more questions and a few more things. So first, let me real quick. I noticed a big Iowa Man 83. Thank you so much for your super chat. That is amazing. $50. Really, really appreciate it. We also had $100 from Mogu, preview of the shot from Mars. Yes, absolutely. Thank you so much, Mogu. That is huge. And we also had $69.42 from T to Nias J. Thanks always for the streams, Tims. Think they're on track for potential tower catch of the ship if things go well with the ship today. Personally, I'd think it makes more sense to do a Gulf landing with ship before a tower catch. Yeah, I think they'll likely go to orbit even before they go for the first ship catch. I think they will do something similar where they allow it to go into orbit, prove that they can deorbit, which still might not be until about flight 15. But yeah, thank you to especially those of you. Those are extremely generous super chats. Really, really appreciate it. We have some replays here that we're going to go through and talk about. And I'll get back to answering a few more questions. And then I'm probably going to get off air and get some tacos because it's It's taco night. But yeah, we've got some replays here that I think we're gonna bring up on air. I don't know. Oh, here we go. This is launch from North Beach. Oh, look how quick that thing shoots off the pad. Wow. And this is from, this right here is probably from Rocket Ranch Outpost, or the highway. This is from the highway near on Highway 4. Oh, look at, I love that exhaust going off to the left like that. Wow. Oh man, it just scoots off the pad. It really just gets out of there in a hurry. Amazing. Okay, this is from across the street at Starhopper. And I wonder how quickly this will be occluded by clouds. It'll probably get occluded pretty quickly. Let's see here. Start up and oh, you can just see how fast that thing is launching. Oh, that's going to be awesome in slow-mo. I almost pulled my headphones out. Oh, that's going to be incredible. Man, that thing just rips off the pad. The funny thing is it doesn't look like that absurdly fast, right? That looks like, I mean, it looks fast, but it's hard to keep in mind that that's 120 meters tall. That's over 400 feet tall. And it clears its own like vertical in only a couple seconds. That is crazy amount of acceleration. Ah, I love there's a boat just casually going by right now. Like, oh, Spencer, I didn't even remind you to hit record. I'm glad you did this. Wow, this is fantastic. Wow. We don't have audio coming through quite yet on these, but we will now actually, I think, have quite enough. Here's from Rocket Ranch Outpost. Folks, sadly, the crowd thinned out after over a week scrub, but people finally got what they came to see, which is Starship Flight 13 flying. Oh, I love the person dancing right in the lower frame there. Excited. That's the way to do it. That's the way to celebrate right there. Yeah, look at that. That's a cool wide shot. Wow. And here comes the rumble from that even. That is awesome. And another one here from, is this Ryan's? Yep, Ryan's spotting scope from his tracking telescope. Again, just look at how freaking fast that thing launches off the ground. Wow, that's smooth. Our tracking shot during, Ryan from Cosmic Perspective's tracking shot during the, we took that to air pretty much the whole way uphill because it was just so good. You could really get a sense of all 33 engines, how well the vehicle's performing. Got the roll program in there. It was fantastic. Yeah, that's what we like to see. That's what we like to see. And here's a tracking shot. It's going to look quite flat because it hasn't been graded yet. And the crazy thing is this also, we can slow it down to like 800 frames a second or something. Also notice that it starts off really hazy because of all the atmospheric haze, all the atmospheric distortion. And as it gets up, it'll sharpen up right away. And that's not actually the focus. It might be a little bit of focus changing, like physically the focus wheel. Ryan sometimes has to pull that. But a lot of it is literally just getting out of the heat distortion, the atmospheric distortion. Wow. That's crazy. Oh, man. It rolls so quick, too. That roll program is like so fast. That's amazing. Yeah, that's going to be incredible slowdown. That's huge. I love it. I love when it goes well like this. That's fun. That's satisfying. huge shout out then to all you down there at Starbase. Yeah, Spencer for running the whole show, and Andrew for helping out from afar. But of course, Ryan, who got this tracking footage. Always, his tracking skills are incredible, unmatched. I'd say these are amazing. But yeah, we have Anthony out there at Rocket Ranch helping us out now too, helping us get everything into position and set up for these launches. So huge thanks to you too, Anthony, and everyone involved. I mean, there's so many people that make this stuff possible, and including all of you that are watching and supporting. Huge thank you. We wouldn't be doing this without you guys. Amazing. Let me answer a few more questions, then I'll work on wrapping this up so everyone can eventually get tacos in their mouth, the most important thing in life. Anthony, tell my wife Jessica that she needs to pay attention. I hope she was paying attention when it was really cool. Sorry that I missed that during all the exciting times, but thank you guys for watching though. That means a lot. Airzilla rocks. Hey, from Greg and Melinda, aerospace engineers in Grant, Alabama. Keep up the stellar work. Well, thank you so much, and cheers to a couple that's aerospace engineers. Amazing, love that. Seattle Jeffin, get some guac with those tacos. Thank you so much. Really, really appreciate that. That is very generous. Thank you so much. Gina, thanks for all you do. Let's go Astro Awards 2027. Yep, we will get it. We will get that all figured out. And I really hope we can make an even better I hope my big goal is that we can make it cheaper, because last year the cost of the theater went up 3 times compared to the year before. And we just need to find a better solution there. So hopefully we can make it more affordable and we can get more people there in person. Velvet Taco donation. I love Velvet Taco. I've not had that in a while, but thank you so much, Radcliffe. Really appreciate it. Isentropic Retreat is my favorite chill song from Matthew Sinclair. Thank you so much. Don't forget all the songs you hear in my streams and anywhere you can find on Apple Music and Spotify by searching Everyday Astronaut. The intro song was Cryogenic. We also hear Isentropic Retreat and a few other things. So listen into those, because it's fun. I appreciate it when you guys listen to the music too. It's a fun thing to be able to share together. Freddie Zaz, thank you so much for the super chat. WTW, SpaceX stock price prediction when they land Starship on the flipping moon. I have no idea. No one can predict futures markets and stuff, and that's why I hate it, because it's not based on like reality. It's based on what if this, and then even when things actually do perform as expected, the stock goes down because it's overhyped. Or following Rocket Lab for a few years now, it's like a disconnect between reality and the price. Like, it just is so crazy to me that I just don't even pay attention anymore. In fact, it might go down when they land on the moon. When SpaceX first lands on the moon, it'll probably go down. It makes no sense. Chansalkier. My sons, Tevi and Aiden, love watching your stream. Hello from Rhode Island. Well, thank you so much for saying hi, and thank you for watching as a family. That always means a lot to me too. Not Tyler. Do you think you'd ever want to fly in Starship? Well, I used to, and for those of you uninitiated, I originally did have a potential flight to the moon on Starship with the Dear Moon program, and I had one of 12 seats basically. Through a Japanese billionaire named Yusaku Maezawa, who announced this to the world, and then about 18 months later canceled the program after it had been a thing for like 7 years. I knew it was going to take a while. Obviously, I had told my crew and had been telling people publicly that I don't think any humans will be flying this thing for, I know this is 2003, 2004, and I was still saying like 5 years plus, which would put us at like 2028, 29. I think even that was optimistic, and I was trying to be kind of the one to keep people having reasonable expectations. I would fly on Starship once this thing's been flying in a very long time. Once it's been flying for 5 years and they have a ridiculous amount of flight data, sure. At that point, go for it. I'd fly, but I don't want to be the first one on anything like this, and I wouldn't want to be the third one. I don't know. Jester Horace, do you know what the difference is from the Giga hangars are? I work on construction at Cape Canaveral, NASA, and I've always wondered the difference. I don't pay enough attention to those nuances between the different Giga the different gigabays there between Cape and Starship. But there are people that pay attention to that kind of stuff a lot more. Sadly, that doesn't get me as excited as the rockets. But thank you for your support, and awesome that you work out at the Cape. Andrew, plasma surfing, your outrage to chase. Plasma surfing. I like that'd be a good name for a song. Thank you. From Tarker, right behind the heat shield bump is something that is flapping. I missed that. I didn't see too much flapping this time, but sometimes you do see little things. There are like literally like thermal tapes and stuff and different things that sometimes flap around. Not a huge deal. Yeah. From Avs, they have to find a way to recover the ship, right? The data you would get from that would be insane. Like I said, they won't. They don't really have preparations for that. They will not, be going. They do have, according to the space engineer, they do have a very, very, very big vessel off the coast, but I don't think it'd be something that could actually recover the whole thing. And like I said, they likely will sink it, but who knows? If they keep doing that, they might be trying to actually recover it. What would the chances be of them be able to bring that back into shore? I live in Perth and we'll drive up there if they can. I don't think they will. I'm pretty sure they'll destroy the thing and they'll sink it. They got a lot of data this time just with imagery. So that's extremely valuable. So that's what I think. Tim, check plus T plus 7 minutes and 25 seconds, large object at the bottom of the ship. I will, but it's probably just going to be per usual. Like, hang on. Man, 725. That is the exhaust plume. That's not a piece of the ship. That's the exhaust plume way off in the distance. I wish I had that pulled up for you guys to see. Actually, I guess I could. Give me 1 second. Well, actually, I can't. The way I'm sharing my screen with the show is not super easy to do that. But yeah, you can see the exhaust way off in the distance from ascent. It just comes, the ship's moving, and you can see it come from behind the ship, and that's what that is. Good question. Space Geek, what are the chances the recovery team can back up, grab flotation devices, and crane haul it back to Texas? None. I just don't think they'll be doing that. From Daniel Dang, thank you so much for your $50 super chat. Greatly appreciate it. Papa Yua, shout out to my son Waylon in Texas. Great show. Thank you so much. Thank you guys for sticking with it. Aiden Eds, thank you so much for becoming a member. Battlestar Group, if you look back at the side of the profile of the tower, the catch arms wobble after the ship clears it. Just goes to show the power of those Raptor engines and their thrust. Yeah, it is crazy. I mean, it is wild, the forces involved in all this stuff. Big Trav, how good would it be if SpaceX could host Astro Wars at Starbase? I think that'd be bad. I don't want Astro Wars that closely tied to any one company or entity. We want to be ourselves and not be beholden. And it's not like, I mean, even if we were like some super prestigious award, I think that'd probably be worse. We're obviously just kind of a scrappy group of enthusiasts that are trying to recognize the hard work involved in the spaceflight community and the spaceflight industry. But I think that'd be a bad idea. I think that'd be a bad look. Would be, hey, we're gonna host this at Rocket Lab's headquarters. Just feels like you'd be very much in their pocket. And although that probably could help offload a lot of costs and stuff, and offload a lot of things, I just don't think that'd be a good move personally. But I like the idea. It'd sure be nice for me. The 3Dist. Shout out to my wife Desiree, who watches every launch with you. There we go. That's what I'm talking about. People watching this stuff together, hopefully getting excited about this stuff. Like I said, I've been watching this stuff for over 10 years now, and it's still important just to kind of take a little step back sometimes and just go, wow, like that is awesome that something so massive and so ambitious is flying. And just to kind of envision what's going to be like in the next 5 or 10 years. If I looked at 2016 watching, the first Falcon 9's landing, I did not envision a world where we'd see something 10 times bigger than that being caught by a tower. Like that just would have been, absolutely unheard of. So where we're going to be in the next 10 years, I don't know, but that's what makes me excited. So thank you for sharing in that. And thank you for watching with me. I'm going to work on getting out of here so we can get the team wrapped up and everything put away, and hopefully start uploading some files and stuff so we can have a replay for you guys to watch here, hopefully like early next week. It takes us a few days to be able to get those out there. But oh, we had another one come through. I will do one more. DT Booth says, Tim, please tell Elon to build David's sling to bring down Goliath. The Chinese already stole the concept, but the 4 Bluto sling design is so much better, off the shelf, mobile, and can be set up almost anywhere. I don't know. This seems to be working better. It doesn't matter. They could do that tomorrow if they wanted. Not tomorrow, but SpaceX could, or any company could build, a giant sling catching thing if it was deemed more beneficial. Maybe a downship Starship, downship booster catch would be beneficial as far as payload, but it's way less beneficial as far as rapid turnaround and reusability. And I know that's what SpaceX is extremely key on here, is not eking out every kilogram of performance, but it's really more about just trying to eke out rapid turnaround and rapid reusability. So I think that's more what they're going to be doing. So last one, Brent Weddle. Elon is definitely checking the price of outright buying a crane boat right now and running it with Optimus bots. I don't think so. Like I said, I think they're just going to sink that thing. They got more data than they could have dreamed having, being able to look at all the heat shield tiles like that. They actually would promptly scrap it, honestly, if they brought it back. They'd probably tear down a few things, but you'd be surprised how quickly they speak. All right, let's scrap it anyway. So I think they're hoping that it sinks, to be honest. But all right, everyone. Thank you all so much. Thanks to the mods. And again, thanks to the huge production team that helps put this on. Thank you all for watching. Thank you so much for those of you that supported and continue to support on patreon.com/everydayastronaut and that are YouTube members and ex-subscribers. You guys all literally keep the lights on and allow me to make deeper dives than I would have normally pursued. And hopefully these newer videos that are coming out are a little bit on the shorter side and a little bit more, focused on a single topic and not an hour and a half, because I know that not everyone has time to digest an hour and a half long video. So I hope that you enjoy the next one. And next time I see you guys will probably be flight 14, which I would guess it will be already in the next 6 weeks. So I probably won't go down to it if it's not a catch, to be honest. I might, depending, but summertime is my time, baby. Summertime is for me and the family, and time to go outside and be active. And try to, it's like work in the morning and afternoon and then go and do something fun in the evening when the weather's nice. That's the beauty of Iowa. So that's the beauty of the Midwest. It's actually the time that you want to be outside. So yeah, that's going to do it for me, my friends. Thank you so much for tuning in. And we'll see you guys next time. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth and this music that you're about to hear, which I believe is Isentropic Retreat. Find it on Apple Music or Spotify by finding Everyday Astronaut. Down to Earth for everyday people. Goodbye, everybody.